Get our recording started. I apologize. We're going to be missing a little bit of that. Okay, so if I look down here, you see these coordinates are like 1, 8, 3, 1, blah, blah, blah. They're whatever they were when I created the points yesterday. But if I look at these points now, those points, look at points 1 through 9. Notice their values are, 900 and then negative something or very small numbers, and they have elevation. So they're not the same points, are they? Nothing tells us that yet. We can use this as a way of getting confused, or let's find out through a couple of things. If I just double click any part of this point, that's going to bring up the point editor for that individual point. So if I double click that, what does it tell you? It says, hey, guess what? Your point number 1 in your drawing doesn't match your point number 1 in the coordinate file. It misses it by this amount. Which coordinate do you want to edit? Well, if I edit the screen coordinate, it will bring up this stuff. So that will show up my screen. There's my elevation of 0. There's my magnail description in my drawing. And so I'm going to, you can make any changes you want to do there. If I say cancel and dismiss it, and if I do that once again and choose the file version, that's what I did. Let me go to another one, say point number 3, and let's use the file version for point number 3. And see what is, oh, I'm sorry. I want to use the screen version, not the file version. So the screen version then brings up to where it is in the drawing. And now it has an elevation, whereas the file version, it was all set at 0. So if I were to do that and then say, okay, then you would see that elevation changed. Right? And so now that one matches. If I go double click it, I don't get that warning. They're in sync, okay, for that one. Now I don't want to have to do it for each one of those. So I can use that utility that I had before, either from the coordinate file utilities command, or I can do it from this point utilities command down here, where you either update the drawing from the coordinate file or you update the coordinate file from the drawing. So let's do that. If I go to points, coordinate file utilities, let's update the drawing from the coordinate file. So if I choose that, and I tell it, okay, I want to look at a particular range of points, you can restrict it to that, or you can say, just take them all. And you can erase points from the drawing that are not in the coordinate file. That's one option to turn on or off. Or you could also draw points from the coordinate file that are not in the drawing. You don't have to do either one. You could do both of those, and then you can choose, what to use from those particular places. I'll say, okay, tells me, okay, I've drawn 22 points, and now it's going to pop me back into this. I'll just list my points. I'll go to all, and you'll see everything except that point 1 is now back down where it's supposed to be. Point 1 is there because remember I did that double click edit and I just said okay because I was using the screen location version. So I've got that particular point that is going to be way off into this location where we are now. The rest of those points are going to be down here where these were in the original coordinate file. Okay. So if I exit that now, when I do a zoom extents, you notice everything sort of looked like it disappeared. So I can see this little bitty grouping up here, and I see I've got, there's point 1, there's point 2 and 3. So if I double click that point 2, I'm still missing that location. Let me do I have in here? Okay, so I've also got these points. That was the point 1, 2, 3, 4. That was the original. These are those original 1 through 22 points. Except and there's your point 9, 10, so 6, 7, 8. Now I've got a point number 6 here that has these coordinates and this elevation. And if I go back, let's go back to my zoom extents. Let me go up to this. These actually should have gone away. Well, let's see what happened. I've got a point number 6 up here. And that's where it's telling me, see, I've got I've got 2 point number 6s in this file, one of which is the old location. And I didn't want those to be in there. So let's see if I missed a setting here. If I'm doing this update drawing from the coordinate file, I said, here's what I did not check. That was the problem right there. So now I actually have 2 point number 6s in the drawing because I did not turn this check on to say erase the points from the drawing, take them out of here that are not in the coordinate file, and then draw these points. Well, no, that doesn't make sense. But let me see. I say, okay, it updated 22 points. That's not working the way it should be working. So I've got everything here. I should only have this 1 point up here. That should be the only point 1 that remains. And I've also still got these duplicated points. Utilities. Update the drawing from the coordinate file. And the points to update 1 through 22. Erase the points from the drawing that aren't in the file. And draw the points from the file that are not in the drawing. And so both those conditions already exist. And yet I've got that set of duplicates. If I draw, well, here's one way of doing it is now I can either allow duplicates or I can erase and redraw. So let's erase and redraw. Now this command that I'm running now is on my points menu to draw locate points. I'm going to just draw the points all over again. I'm going to say erase in my duplicates, erase any points and redraw. So it's going to read all the points from the coordinate file and draw them into here. So I'm going to just say draw all. And now you saw that change scope because it's now appears where our last one was, and it should. Okay. There's point 1. Wow. It is still giving me those duplicated points. So they're over here. Hmm. So this is point number 3. That's the new ones. With that elevation, there's no description. And when I double clicked that, it popped right up and it says, here's the coordinate file, exercise 1. Yet if I go back to here, I've also got a point 3 just floating around loose in my drawing that I And that's where I get this, because it says, hey, there's a difference in where this is here and where it is in the coordinate file. So all of those redrawing should, if I draw, let's say 1 through 9, draw locate points. I'm going to draw a range of points 1 through 9. Duplicates should erase and redraw that. I think what's confusing it is that I've got not really duplicates, I would have triplicates. I've got 2 in here, so these still did not go away. All right, so to update this, sometimes I would simply erase those particular points. And you can either erase the points with the command here, or you could simply select and hit the delete key. So now they are not in the drawing. I double click. There's my points, my new points. And if I now draw locate points, draw all, and you saw those go away because I still have that one lone point, that point number 1, that is out there in my last location. It should be right there. That's that single point 1. Yeah, because it's editing that based on the double click edits. So anyway, so you can see how it can sort of, I'm trying to say on using points, and it's you know, it's not all that impossible to actually get these things a bit confused and overlapped. So, but in any case, what we can do then, if you get a situation like that, there's several ways around it. You can either update your drawings, and the easier thing to do then it would be to, or not the easier thing, but the guaranteed thing to do is to erase them completely out of the drawing. And then you can draw them back from the coordinate file if you need. Now, I've got a case here now where my point number 1 is not the same as the point number 1 that I started with, the one that I used. Now, remember what coordinate file I'm in. I am in this one called exercise 1 coordinates because I switched to it. But now that point number 1 is different. I want that original point number 1. So if you've got a situation like that where your coordinates are all just sort of screwed up, there's a way around that, and it's based on these settings that we did yesterday. This under settings, Carlson configure, and it's under the survey settings. And that was where we told it to use our point history. And of course, I'm lying to you. It's not in the point settings there. It must be under, yeah, I'm sorry. It's under our general settings, but it has to do with this object linking, is maintain the coordinate history file. So sorry, not survey settings, but general settings. And the object linking, it says maintain this coordinate history file. Now that's just a file that has, if we look at, let's do it more familiar territory. If we look at the our folder where we're working, and across some projects, fundamentals, class data sets. Now look at the, if I sort by type, there's a file here called, there's the first exercise, HIS, that was from yesterday. There's exercise 1, coordinates, HIS. It's just a history file. In fact, if I double click it and just choose the notepad, you're going to see that it is, it's got a name here as to what version, etc. Then it's got some binary data. It's got the user that did it, who worked on the file, that sort of thing. Okay. So, but that, as long as we track those files, we have a means of rolling back whatever we may have done. So I'm going to go to points, and I'm going to go to my coordinate file utilities. And I'm going to come down here to the bottom right where it says point history. I'm going to click on that, and I can see a couple of things that have happened. I've got, under these two tabs, I've got commands, and there was one where I did that edit. And I've got points, and I can see where I've got point number 1, 2, 3, it goes all the way down to 22. And point number 1 had an adjustment to it. So you see those particular state plane coordinates that was brought about by that edit. Okay. So I can undo either one of those and it should reset me. So if I go to that command and select that edit, and if I undo that, sure I want to do that. Yes, I am. And now, whoops, didn't mean to do, button, turn it back on. So now I'm going to say, take a report. Let's take a look at that. And it says, okay, here's my coordinate file. There was the history file. Point number 1 was changed. Here's my old values. So it's now updated this. If I close that and list the points now, my point number 1 is back to where I'm in that same range as all my other points. I can exit that. I can then, go and draw that point again. So if I go to points, draw locate points, let's just draw point number 1. There it is. And that's the only point I've got in the drawing at this stage because I erased them all, but the coordinate file had the points in it. I can draw them all, and now I am back in business. Okay. Everybody sort of follow the functionality of what we can do with these groups of points. So now talking about how we use those from yesterday, we've already sort of done most of this yesterday. I'm going to let you take a look at on your own when you go back and review this stuff. I'm going to let you sort of work through this exercise to get a little bit more of the nuances here. And there's one tip right here that you can see, that instead of changing a particular coordinate file, you can do that as a little shortcut. When you go to draw locate points and the coordinate file shows you what is currently set, then you can hit the set button, and right in the middle of that particular command, you don't have to run that command first to set the file and then do the draw locate. So little things like that you're going to see. And whether or not you're going to draw 2Ds and 3Ds. So if we look at, let's see what file we're looking at, the draw locate points, exercise 1. Yep. So that's the one we have. Okay. So if you have not done so, let's go to the points menu and choose draw locate points. And here's where this coordinate file, the very top line, one that's often easy to overlook. Make sure that says exercise 1 coordinates. If it does not, hit the set button and find that point, or that file rather, that point file, and choose open. Now, you can hit that set button and choose that file. And it's going to draw the points from that file. I'm not sure whether it will have the effect of making it current, making that file current, like pulling down the file menu does, or the points menu, and choosing set coordinate file. I know we'll get the points from that file to draw with, but I'm not sure whether that makes the set. So keep your eye on the list up here at the top as to what's current and whether you need to change that. So in any case, we've got exercise 1, coordinates should be open. We've got 22 points in there. Let's just say draw all, and there they go. They should look something like that, which should look like this arrangement in your manual, okay? And now we already did a couple of things yesterday where we said draw a 2D polyline, and we started drawing and we used point numbers, etc., etc. But these particular points, notice there are point symbols, there's a point number, there's this elevation number, but there's no description, okay? In fact, if I double click that point, I see that I've got a point number, there's its location, there's its elevation, but there's no description, either a drawing description or a coordinate file description, which they can be different. Okay, you can have a description in a coordinate file that is not in the drawing or that differs from the one that's in the drawing, or you can have something in the drawing. Once a point is in, you can add a description to a point in the drawing that does not store in the coordinate file if you so choose. They usually do. They're usually one and the same, but there are times when we want them different. For instance, it's a process called field to finish that surveyors do a lot of. And maybe they've got a point in a coordinate file that just says FH. Okay. But in the drawing, they want that to read the full words fire hydrant. Well, then you could have something, along these lines. And so you see now the description is in my drawing, so it spells it out in a little more detail. But if I look at my list of points, whoops, list, you're going to see all of these descriptions up here are blank until I get down to here, and that description says FH. If I double click the point, again, you see that FH in the coordinate file, but fire hydrant in the drawing. Okay. So now what happens if you get rid of this point, for instance, and redraw it? Well, let's just redraw it from here. Points, draw, locate. Draw range, I'm going to draw point 17. So what happened there was it went back and read the coordinate file description. And because when I said, and let's change that now to read a little bit differently. It's going to read hydrant in upper and lowercase. So when I told it to draw locate points, I said to erase and redraw. So it erased that point 17 where I made the edit, reread it from the coordinate file and redrew it. Now, if the other option here was to draw only new points, and I said draw 17, see what it says down below? It says points drawn 0. I skipped it because it already existed. It wasn't new. So it left it alone in this case in my draw locate command. The other option then is to allow duplicates. Now this is where it gets weird like it did before. And I'm going to draw point number 17 again, and you're going to see there's 2 points there. One's 17 with this location. They're written over top of each other. I'm going to show a little neatening command. I'm going to go to the points menu, and I'm going to come down to this section of the menu in this block here that deals with the attributes, and I'm going to move the attributes with a leader. So I'm going to click on the one that says hydrant, and I'm going to move it up here, and I'll take the one that says FH and move it over here. Okay, so now I've got 2 point number 17s. If I look at that one here, that's its location. It has a drawing description of hydrant and a coordinate file description of FH. This particular one, you see, has FH for both. Notice these coordinates, 902, 264, minus 600, 513. These coordinates here, 902, 264, 600, 513, they have identical coordinates, but I moved this up here and I moved this down here, okay? But what did I not move? I did not move the actual points itself. So when I ran that command, move point attributes with leader, all that's doing is moving the, if I take this now and restore it, those are the attributes. And you can do that with that command that we just did, move point attributes as a block, or you can select that and you can actually move these individually anywhere, wherever you want. Okay. And even the same with this, and because I've moved that as a block, now that's got that extra little arrow that I can simply delete if I wanted, or move point attributes with the leader, and one of my options down here is to restore. And if I pick that, it will restore those back. Okay. So now I still have 2 points right in the same location, but if I, instead of grabbing the attribute grips, if I grab this grip now and put it down here, I will have 2 different locations. So it asked me, do you want to update your coordinate file as a result of moving this 0.17? So there's the old location, there's the new location. If I say no, then it won't do that part. But of course, if I say yes, it will change its location to this new location. And it not only moved that one, but you notice this one up here jumped up there to move with it too, because that is really 0.17, even though I've got 2 of them drawn in the drawing. Okay. So a lot of different things you can do, and it can be easy to get, to get some things confused. So just think your way through it and you'll be just fine. Just remember where these things are coming from and look at these options, things like allow duplicates, draw only news, erases and redraws, etc., and you'll be in good shape. Okay, so now I've got, again, these 22 points. So a couple of other things I can do with that. If you draw, go to the draw menu and let's draw a 2D polygon. And let's just take the defaults and then say, okay, and let's draw, you either pick a point number, but let's just draw it like 1 through 22. That's all my points. So now it started there at point 1, went to 2, 3, 4, 5, 6, 7, 8, 9, 10. So that was pretty handy. And it's now still asking me for the next point. And I can keep drawing other points, or I can finish the command by hitting enter. And it's done. Okay. Now, let's draw this time instead a 3D polygon. And I'm going to set its color to be, let's go with this magenta so you see the difference. And I'm going to say, okay. And I'm going to say 1 through 22, very same thing I did. And hit enter and finish. Okay, I've got 2 different sets of lines drawn through those points, but what would they actually look like? And I'm going to hold the shift key down and I'm going to press and hold the wheel on the mouse, and I'm going to roll it up slightly so you can see what's getting ready to happen. Okay. One of them is flat down at 0, so I can look at it sort of edge on. And the other one has the elevations of those points. Okay. Everybody see that and how I'm doing this manipulation? I'm holding the shift key and using the wheel on the mouse to zoom around and see the results of what I've done. Now, when and where would you do something like that? So let's say, we've got some points that have elevations on them that are meaningful. Let's say they are the result of computing some things, or maybe surveying out in the field some different things, but I want those elevations to be used for part of my design, either an alignment or the outside edges of a parking pad or something like that. So it now becomes, a fairly simple matter to draw that information based on the elevations stored in those points. And if I say use a 3D line work as I'm drawing it based on point number, it's going to read the elevation of the point. But if I say draw a 2D line, then it's going to only use the, either a starting elevation here, or if I say set the elevation by the first point, let's say I'm going to go from point, say 13 to 7. So if I say 13, notice it starts at that elevation, and I'm going to go to 7. Well, now you can see it set the elevation. I'm going to just look edge on. So it started at the elevation at point number 13, and it held that elevation, and it went to the horizontal location of point 7. So if I look at that in my plane view, I'm just going to go over here to my view cube and hit the top button. So now I see I've got this one that started on that 149,111. If I look at that line in my properties, I see there's the actual elevation for both vertices. Okay. Whereas this 3D polyline will have varying elevations all along itself. Okay. So that's sort of some ideas of what we can do. Another reason we sometimes will do this, where we've got multiples and duplicates of different, this I've got one as a 2D, usually down at 0 elevation, and the other is a 3D. The 3D lines are going to be what I'm going to use for design and modeling, whereas the 2D lines are often going to be used for line styles and line, different things that I'm going to indicate. So if this were an alignment, I wanted it to look like a center line, I'm just going to go ahead and select both of these lines. And even if I'm looking at it straight down like this, to select both of those, remember, if I click and move to the left, it becomes a crossing window. And I click, I've got now 2 things selected. Okay, but I'll show you the effects now by looking at it like this. Let's change the line type over here in the properties. And I want to pull that down, and I want to make that a line type of anything that you want. There's a center line. Let's use a center line. Okay. Well, what happened? Well, obviously, one of them changed, the other one didn't. Okay. But if I select that and I look at its properties, it says that it's using a center line. but this is the only one that shows up. Now that is a known characteristic, or I even like to think of it as a limitation of the AutoCAD drawing format, is that it cannot show patterned line types or those line styles in three-dimensional lines for whatever reason. The programmers decided never to do that. Now, other programs like MicroStation, that's not a problem whatsoever. It always recomputes and redisplays this line at whatever angle you're viewing it. It just updates it and keeps it, lets you use that as a particular line style. So when we're dealing with these things, if we've got some three-dimensional lines in our drawing, and if we need those drawings or want those drawings to be a particular line style, they have to be planar. They have to be in the horizontal plane before they'll take on that line style. So if I go back to this in plan view, and if I wanted to see that as a pattern line style, then I need to freeze the layer that this is on, and that's 3D BKLN. I'm going to run my layer manager, which is this little button right up here beside my properties. I'm going to find that layer, and I'm going to come over here and say freeze. And now the only one that's showing is that one down at 2D, even though I used the points to create the one at 3D. Okay. Now, I'll put that back visible again and show you the sort of the nub about what we're going to be using for surface displays. We're going to build a surface, and even though we might have this 2D polyline in our drawing because it has a 0 elevation, we're going to tell it to, it can just ignore things with 0 elevations. Okay, so when we're building a surface, remember I said the only thing you have to worry, or the only things that you're going to be using for things to define those triangular patches along the ground surface are points and the lines that have three-dimensional information. So in this case, I've got actual Carlson points. I also have a line, 3D line. I'm going to draw another 3D polyline. And this time I'm going to show you a little trick. I'm going to say, go from that, I'm going to go back to my plan view, and I'm going to go from, say, point 11. So point 11. And I'm just going to click a couple of points out here. And let's say I'm going to go back to point 8 and be done with that. Now, what does that look like? If I used that elevation there, 143 something, and I went to 121 something, what about these points out here? What do you think those are? And the answer is, let's change the color. Okay, so it started on that one elevation, and then everywhere else I clicked, it dropped it down to 0, and then I came back and clicked it up to here. Okay. Now in our civil tools, we have a way of sort of resolving that with a particular edit that we don't have in Survey. So I'm going to go to my settings menu, and I'm going to go to my Carlson Gosh, they keep. Well, there it is. It used to be up here a little higher. Go to my Carlson menus. I'm going to switch to my civil menu. If you have the civil module at your installation, you can do that as well. You can switch to that to get this particular command. I'll show you sort of a little preview of that. So now you sort of see how that works there. I started at that elevation. I wind up at this elevation, but in between, everything got dumped down on 0. So let's suppose I wanted that to go smoothly from that elevation to that elevation all through its length. In other words, interpolate along there until you get, to the final elevation. And if I've switched to civil, and if I go to my 3D data menu and I look at this polyline elevation editor, and if I pick that polyline, notice it brings up this little thing, and you can see a little preview of the line in a profile stance. And let's say I take number 2, and let's say I make that an elevation of, see, we start at 143, and let's make that an elevation of 150. And then see how it's pulling that up. And let's say we made this one, say 100. So 100. All right, so now I've got a case where I start at 143.369, I go to 150, I drop to 100, I'm back to 121.712. But what I can do, if I uncheck these two in the middle, it releases the elevations that they had, and they go from 0.1 to 0.8 smoothly, ignoring the points in between in terms of its elevations. And if I just say, okay, now I look at it and it goes smoothly from the starting location down to the end location at a particular slope. Should be a constant slope, right? In fact, if I go to my inquiry menu and I want to find some information out about the polyline, I'll choose that. I'm going to choose this pink one. Remember, that went from each point to each point. So if I click there in the middle, it tells me that has a slope of 3.39%. And if I do it again, I repeat the command, for the next segment, that's a 3.39%. Let's see. That's the timeline. So it's giving me that. Oh, that's the 2D at 3.39%. There's the overall. I think it's confused because I'm not in plan view. Let's go to the inquiry menu and switch to a different command. Let's choose the drawing inspector on and off. And let's see if this works while we're rotated. So now the inspector is on, but I need to choose what I want to look at. And it tells me on the command line, inspector on, right click to activate the pop-up menu. So I'm going to right click that, and I'm going to make sure that I'm going to, whatever these are, I'm going to turn on and off what I want. So I'm going to turn off anything that's set, except I do want to see my polyline data. So I'll right click to make sure that is checked. It is. I now, just as I hover the mouse, there's that 3.39% slope. The current distance, a horizontal distance of 182.88, 182.94. start and elevations, then the total distance, and the current distance. This is not. Yeah, that's what I was thinking, is it's not reading it correctly because it's not in. If I just barely go out of here so I can see it now, I've got, no, it's, apparently it's got to be in plan view for that thing to work exactly right. Let me isolate by selected object. All right, so now if I hover, there's 3.39%. I don't. Well, actually, I think that might have worked. I think those points just happen to all lie on that plane that's 3.39% between points. That's, it might be. If I inverse 14 to 13, yeah, 5.659. $167. So, yeah, 3.39%. Yeah, okay. So these points actually, it is working just fine. But those points were created originally from a line that had a constant slope of 3.39%. What I was trying to show you was that this purple line, being the one that went point to point to point, could be at varying slopes along those edges, but we can, just like you saw here, it went from this elevation down to 0, 0, 0, 0, 0, 0, up to this elevation. But we smoothed that out with those particular, with that edit on that 3D polygon. Okay. So just some tools that we can use with that. There's another way to get to, yes.
Quick question for you.
Wait a minute, I'm sorry, I couldn't hear.
Now?
No, I got you, yeah.
Okay. I just had a quick question. When you went and edited those zero elevations on that 3D polyline, how did you get to that?
Yeah. Well, if I did this, if I do a draw 3D poly, and let's make that, again, we change that color. So I'm going to now use point number 11, let's say. And that, you see, reads that elevation, okay? And now I'm going to just pick points here, and if I do that and you see it reads that elevation as 0, it says, warning, the last 3D polyline is at 0 elevation. Well, I'm going to ignore that. I'm just going to go along here, maybe even come down now to point number 5. So 5, hit enter, and I'll hit enter there. So now what I've done is, that was originally, you see what that is and how that looks? It's sitting, all those other points are down there at 0, except for the 2 that I use point numbers. Because that's a valid 3D polyline. Now, to get to that point where I made that edit, is I switched to my civil menu on my settings, Carlson menus, civil menu. Okay. And I then went to this 3D data, and that is the polyline elevation editor. Okay. And if I choose that and I choose that polyline of interest there, I get this little control over here that lets me edit that polyline. Now I'm going to look at some settings here a minute. I want to label control points. I want to uncheck this hide non-control points. So I want to see them when they come up. All right, so that particular file went from 143 down to 0, and then all these points in between stayed at 0 until the point right before the end, it went from 0 up to the endpoint. So we have what are called control points and non-control points. The control points have a checkbox in them. So if you uncheck a particular control point, that releases it from whatever elevation it previously had, and it computes its new elevation based on the slope of the before and after vertex. So if I only hold the first and last elevations, that now distributes that change, and you see the slope is constant all the way down that line. And you can either, if you know the slope, you can type it here, or you can just let it compute. You can change elevations. You can even, let's say I go to the point here in the middle, point number 4, and let's say coming down into point number 4, I've got a negative 2.5% slope. So let's say I go from a 0 slope into that point. Okay, so I'm going to go 0. So now it's horizontal all the way out to point 4, and then it climbs up to point 8 and redistributes that slope. When I say okay, that's now you're going to see, if I go into this edge on view, in fact, let me just click the front, and I see this guy, and it goes from 1 to 2 to 3 to 4 horizontally, which is right out here, 1, 2, 3, 4, and then it starts interpolating around to my end elevation. Okay. So that's just a really nice little editing tool that's available in Civil. It's not, unfortunately, available in the other modules. So I think you said you all have the Civil module, so that's something you probably want to get used to using. There are ways, though. Let me put this back. Put this back to where they were. I'm gonna undo that, do this, and change this to 0. Change this one to 0. Okay, so there's a couple of ways around that. Let's see, let me go back to survey just so I don't necessarily want to, I'm going to be sort of in my plan view. I want to see if I can figure out a tool that can modify that. If I say, right, let's see, if I go to set point elevations by 3D polyline. I think what I'd have to do is set points along here. So what I want to do is I want to interpolate points along an entity, elevation between, along entity, interval between. This might do it. Interpolates. Relation between pick a point or a point number, so that's point 11. Point to interpolate 2 is 5. I think I missed. There's point 11. And a point to interpolate 2. At a single elevation or an elevation interval. Say go by interval. Test. Okay, so see what that did is it put points, it interpolated all of those points from the start to the end and set them by an interval of every 5 feet. So that's obviously not what I was wanting to do. I was trying to set if I interpolate points between points, how about along an entity, an interval or elevation? All right, so if I say an elevation along an entity, I think what that's going to do is read the actual entity itself. So it's not quite exactly what I'm looking for. I may have to use that command from Civil. So the entity I want to use is this. At a single elevation. Let's go with an interval, and then of course it's going to ask for elevation range N to start at top, no, it's 2. Yeah. Yeah, so I thought. So it's going to go from here and drop it 5 feet all the way down to it hits 0, and then it quits doing it until it gets to 0 and starts climbing up again. So neither of those commands are really what I was looking for. But here is a way around that sort of up front. Now I'm going to get rid of all of these extra points. Don't want to get rid of that one. I do want to get rid of that one. And let's toast. All right, so what I could have done instead of letting those things go to 0, and this is the case of where you're going to need to know this information up front before you start, if you don't have that Civil editor. If you draw a 3D polygon, and now this time I'm going to change my color to something else so you see what happens with this one. And up here is my options. I've got this prompt for an elevation or slope. Notice it was not on before. That's why it read that elevation, and it read the elevation of where I clicked, which was 0, 0, 0 until I got back to that point. So now, if I want to set this in correctly, I'm going to tell it to prompt me for that elevation. And notice you got the option to do like an elevation adder. An example, guys, would be, let's say I'm going to lay out um, say a water line that needs to be 4 feet below the ground to keep from freezing. All right, so I would say, either prompt me for the elevations, and then I'm going to put an adder of -4 on that, or I could even say, instead of prompting me for it, I can say use a surface model from a file. So if I have a design surface, I could be prompted for that. And then when it starts to lay those points down, it's going to hit that file. And I would put that -4 feet in there as well. So we don't have a file. I'm just going to say prompt for the elevation slope. Now watch what happens. If I say, okay, I'm going to go from point number 11. It reads the elevation, 143.3586. I accept that. Okay. Now, the next point. Well, I'm going to come up here and I'm just going to go right over top of this same one. And I'm going to snap to the endpoint because I've got my object snapping on. I'll click, and it says, okay, I click that point and I see that it has an elevation of 0, but I don't want to use that elevation of 0, or maybe even I clicked on something that had an elevation and I didn't want to use it. One of my options is, if you look down on the command line, is to interpolate. So my next point or elevation or interpolate. So if I type I to interpolate, it says, okay, that elevation will be interpolated once I finish. Okay, so I'm now going to go to the next point number here. It's still being interpolated. I'm going to keep being interpolated until I hit a elevation. I'm going to come up here to point number 5. And now I hit enter, and I've got, with exception of the fact that I missed reading that point. I'll scoot this back over now. Okay. So now green up. When I started, I snapped to that. So now what you see, the blue line started at the point, dropped to 0, came all the way around, and then went up and ended at that other point elevation. The green line said, all right, I'm going to start at this point. I don't know what these points are going to be coming around the horn until you get back to when I should be looking at that. Let me do this over again. I think I missed something. Let's see. If I go from there now, draw 3D, prompt for, we'll say okay, and let's start with point number 11. There we go. It read the elevation correctly that time. And now I'm going to go to here, but I'm going to say interpolate, pick all these around. And then 5. And that should, think it, no, it's still, it makes it down here to 0. Go from 11 to there by interpolation, there to there to there to there to there, and now to 5. Okay. So now. Something. Three D polygon from 11. Reading the elevation, 143.36. And accepted that. It goes to the next one here that I'm going to interpolate. Okay, it says it will interpolate. I keep going. I want to go to point number 5, which is 109.93. So if I take 5, it's like it's not finding point 5. There's something. That reads 0.5, 109.92. Something going on with that, guys. I'm not following exactly what that is. Does that have a non-zero elevation? Ah, that does. That's exactly what that is. That particular point has a non-zero. So that's a 105.40. That one is, nope, I'm sorry. It does have a zero elevation. 878.16 comma 0.00. Yeah. In any case, let's not go down this rabbit hole too particularly far, but those are some of the tools in creating that 3D polyline that if you know ahead of time, you can have it interpolate along, or you can assign individual slope values for each segment as you create. And that's all in this draw 3D polyline. And let's draw, say, from point number 11. Sorry, 11. It tells me its elevation right here, and I can accept that and then pick another point. Let's say if I go to this point, it tells me that has a Z of 0, or now at this point, I need to give it an elevation, or let's say I go a P for percent slope, and I want to do a negative 2.5%, for instance. Okay, so that now has set that at a negative 2.5%. And you see that has a horizontal distance of 205.94, slope distance of 206.01. There's my percent. Okay. And then if I click another point, now how do I establish that point's elevation? It keeps the last thing I used, that was my percent slope, or I could say a specific elevation if I type E. Let's use the elevation of, right now that's its computed elevation. But let's use the elevation of this point of 138, of this 131.42. So I'm just going to type 131.417. All right, so that now has that elevation. So that's going to, this is coming down at a 2.5% slope. That's going down to the same elevation as that point. And if I click, say down here, and let's say I switch it now to interpolate. So it's going to interpolate until I finish up. And let's say I want to go to point number 5. And at that point, See, it's interpreting that point number 5 as an elevation. So let's undo that segment. So now I want to go to point number 5. So that would be, I'd have to switch it to this, pick a point and say point number 5. There we go. That would have fixed that last one to begin with. All right. So let's get rid of this. Now that I know what was going on, we're going to draw a 3D polyline, prompt for elevation slope, and say okay. And I'm going to start with point number 11, accept its elevation, and I'm going to go to here, and I'm going to set that elevation by interpolation. Go to here, to here, to here, to here, to here, and now I want to go to the next point or elevation. So I'm going to say next point. And that next point is going to be 5. No, darn it. Undo. Pick a point of 5. No, undo. Let's pick that point. Also interpolate. And now let's go to point 5, which if I snap, it reads it okay. Now there we go. Is that as I started at that point elevation, went all the way around and closed at that point elevation, and it interpolated a continuous slope from start to finish. Okay. And there's also, let's see, we could do one other CAD edit on that. And in my edit menu, polyline utilities, 3D utilities, if I want to do this by start and stop elevation, again, I think I have to be on my civil. Yeah, I would have to have my civil module loaded to be able to do those other 3D manipulations. So if you're doing a lot of design work and if it's not specifically survey related, civil is going to be the tool that you need to use with that. Okay. So now we're way past, we missed our mid-morning break, although we're gonna go ahead and take it. We'll come back at 11:30, but I don't want to get too far afield and get down into this rabbit hole. So what we're going to do is when we come back, this is basically that exercise that we were going through. And then we're going to talk about point groups very briefly as to what they are. They're just means of organizing your points. Okay. And we'll do a real quick exercise. We won't be the same, won't be as complete as the previous one because we need to spend the afternoon doing these surface models and how we're going to build those surfaces and go through that little exercise. Okay, so I'm going to leave most of the details of the rest of that point discussion to your further work on your own. Okay, so let's go to here. I think we will be done with this. You can save this file if you like. What have you been working on? Or we're going to come back and start with a new one. All right. So let's go ahead. It's about 19 after. Let's come back at 11:30 since we're getting a little bit behind the time. So let's come back at 30 after the hour. Any questions you might have before we go? Everybody good? Okay. All right. So I'll also all right. So we're going to now talk a bit about surfaces and terrain modeling. First of all, how much do any of you folks grasp about this concept? First, let me ask you about the concept. I'm sure you probably understand that surfaces are modeled by these triangular planes, all edge to edge, and they're defined by the points at the corners of the triangles. But who here is familiar with and very comfortable understanding what break lines are and what they're used for?
What do you mean by break lines?
Okay, those are the edges in a definition of your data set that control how things work. If that is an unfamiliar concept to you, then that's fine. We'll go over that, and it's crucial to understanding how to model your surfaces, but I don't want to spend a lot of time if everybody's comfortable with it. How about you, Amy? Are you familiar with that, or is that going to be a new concept as well?
New concept.
Okay, no problem.
Yep, new concept for us too.
Yep, great. No problem at all. Here's how they work. And there's a real simple rule. And a lot of other, learning about this tries to make it a bit more complicated than it really needs to be. They talk about break lines as being lines along which the grade breaks. And that's true, and as far as it goes, and that's where it gets its name, but there's an easier way to think about these. And here's where it's going to come from. If you, and I'll leave this page in your manual. Are you guys seeing this?
Yep.
This page? Okay. So I'll leave that to your own sort of in-depth study. Talks about what we use to define the surfaces. And it's basically, we use points that have elevations on them that tell us, hey, the ground is this elevation at this location. That's the very simplest form, okay? But now if you look at this picture right here in the lower left of, say, page 19, these triangles are going to form inside the computer according to a pretty complicated but well understood criteria or algorithm called Delaunay's principle. And
sorry to interrupt.
Sure.
So when you say break line, are you just talking like let's say there's a crown in a road, like 2% one way versus like a 2% the other?
Yeah, it's those are what form break lines.
Okay, yeah. Me and Robbie understand that then. Yep.
Okay, so like and here's the reason why, but we'll go over it for Emmy's edification as well. So here's what can happen. If you consider these 4 points, elevation 100, 110, 100, and 110. One potential way that this surface would be modeled in the computer with this very simplistic case is that it would assume the elevations at the 100 corners are, well, first of all, it makes the elevations exactly what the points are in every point without exception. But does this landform work like this, in which case every line that you see drawn between every point makes the assumption when it forms that triangle that the ground goes from the elevation at one end of the line to the elevation at the other end of the line. So if you look at it the way it's drawn here, it shows the ground changing from 100 in the upper left. It climbs up to 110 in the upper right. It also climbs to 110 in the lower left. And then from those corner points, it drops back down to 100. So that makes what's called a saddle or a ridge. There's a ridge line that is 110. It also connects to 110. It says, okay, it's the same elevation across there, but it falls off lower to the left and lower to the right. Now, contrast that with this scenario, which the computer is free to choose whichever one of those works, and it does it based on proximity to the other points, so you don't really know what's going to happen. In this case, it said, okay, at point 100 it goes to 110, and from 100 it climbs up to 110, and then from these 110 corner points they drop back down to 100, and then it's 100 all along this line across the floor of a valley. So you see it goes 100 to 100 and it rises to the lower left and rises to the upper right. Whereas this example has it rising from these corner points here. So this one rises up and rises up, whereas this one, instead of rising up, it still rises up and rises up here, but it says from here to here, it's all that same elevation. So
So that would be an example. That one right there would basically be a ditch. And then the other one would be like a ridge or like a crown in a road.
yeah, exactly right. Or even think about it as, 2 points in a valley and 2 points on either side up on the mountains. Okay. Obviously you need more points than that, and in the case of this one, it would be, these are 2 points up on the mountain, and then this is off in this valley, and this one's off in this valley. Either one of those scenarios without anything governing are correct. Okay, because it goes from 100 to 110, from 100 to 110. So all of that change is correct. These two are correct. And then the change here is these two are still correct. These two are correct, but it says it doesn't change along this line as opposed to not changing along this line. So if you walk this line, the original line, it goes from 110, it falls down to 100 and then climbs back up to 110. Okay. Whereas in this situation, it starts at 110 and stays at 110 to that point. But conversely, it starts at 100, climbs up to 110, and then drops back down to 100. So without anything saying otherwise, it can form either one of those situations. And that's why we need break lines. And really the rule of thumb is that what we are trying to do is we're going to create lines connecting certain points that are going to prevent points on one side of that line from looking across it to points on the other side and saying that that should connect with a straight line. So this keeps point 100 in the upper left from seeing point 100 in the lower right. So it knows nothing about that point. It stops right here at this triangle. Okay, so you'll see sometimes break lines called barriers, and that's really all we're doing. And really the rule that you need to remember when you're setting up your models is right here. If what you're modeling, if I can get this to light up, if your modeling is an edge on the ground, then you need to make it an edge in the data. That's simple. That's break lines in a nutshell, and that's all you need to know about them. Okay, and here's some other examples. You consider this curb that got surveyed out in the field. The surveyors went there and they surveyed points A and B and C and D and E and F and then G and H, and you can see where they are along those structures. But if we don't tell it when we go to model it that point A is not allowed to look across and see point E, then it's free to form triangles like this. It doesn't necessarily mean it will, but it's possible. So it could form a triangle that goes from point A to E and down to C. Now this E down to C, down the face of the curb, that's correct. And C from the gutter line out here to the edge of pavement, that's also correct. Same as C and B and C and F. But B can see point number F and is free to make that triangle edge unless something else happens ahead of time. If this line from C to D gets formed first, then B can't see F. And if we just rely on the computer to decide where those lines are going to go based on point proximity, we are either requiring ourselves to make our points denser and closer together all in one spot, whereas really all we need to survey here is a point on this line, a point on this line, and 2 points on each of those lines. But then we need to draw in the drawing the lines that are going to prevent those from happening, so that instead of these potential errors, we get something like this. So we're going to have the computer draw for us the line that goes through points A and B, the line that goes through points C and D, the line that goes through points E and F, and the line that goes through points G and H. Edge of pavement, face of curb, top of curb, back of curb. And when we do that, this line that forms between, say, that forms along the gutter, keeps the point out here at point A from looking across it and finding point E. So that line will never form a triangle edge because there's something in the way, okay? And that's what break lines are and how we make them. So now up here, and again, I'll leave this to your sources where we got the modeling process and how we can look at those sources. But the key to making your surface modeling accurate and successful is this right here: evaluate, evaluate, evaluate. And the easiest tool that we have a number of different tools and they're discussed here, but the best tool that we have is simply our eyes, okay? And right up here, you'll see that. So use your own eyes. And so we're going to learn to take a look at our data, see what we have, and see if we need to fix things. So right now, if we were to look back at, say, this data, this is a zoom, let me go back to this. This is a zoomed in area. Sorry. This is well, let's get it, settle down. All right, so this is a zoomed in area of our map. We see it in plan view. So we can't really tell anything about it. But our understanding is that points out here along this edge of the road are not going to be, or should not be allowed to look across and see points on this other side of the road to form faulty triangles. Same thing along this driveway edge, okay? So if we look at this in 3D, we look at this situation in which we see that, okay, if those edges are at elevation, that keeps, say, a point over here from being able to look across and seeing a point over here and deciding that that is a straight line change. It says you can't cross that line. So you can only go from this point to another point along this line to form that edge. And then from that point, you can go up to, again, there's that line in the middle, that center line, that's the crown of your pavement. So that becomes a break line. And that keeps points from this edge of the pavement from looking straight across to the other edge of the pavement and deciding that it goes flat across there when it really has to climb up to the crown line. So when we look at this, we can see, same as the center of the stream, everything appears to be at its proper elevation. Sometimes you'll get data like this where the break lines are all elevated, but the edges of pavement and center lines of streams might be drawn down here at zero elevation, in which case you need to take those lines and bring them up to the elevation of this data set and to where it needs to go, okay? And there's a couple of ways that we can do that. Is we can just redraw that, or we could have surveyed that information or compiled it from aerial mapping and make sure that we got elevations on them, or we're going to need to find another set of tools that will get us to that point. Now, let me ask you, Amy, do you have the civil module or only survey?
The civil.
Okay, so we all have those tools, and I'll show you where some of those are. They're easier to use and better than what we necessarily have on this other. But so let's take a look at our data. We're going to go back to this example here that we looked at yesterday. So we're going to open this drawing file called sample from T3 Global. Okay, so we're going to come over here. I'm going to close this file. I won't save it. And I'm going to open files. And I'm going to look in my data sets. And I'm going to find that sample from T3 Global. I'm going to say, okay, open. And so here's what we've got. All right, now we've got a number of these elements that are drawn at elevation, and some are not. And if we spin that up like there, you can see very quickly, very graphically, the things that are drawn at elevation and the things that are not. So if we tried to, rely on this edge of the road and this crown line only, and we didn't have a corresponding line over top of it in 3D up here, then we would get erroneous effects down here. It would allow points from this side to look across to that side and incorrectly form those triangles. Okay, so we're going to see what we're going to use to help us evaluate that and figure out where these triangles are going to form. Okay, so let's go back to our top view, and we got a bunch of data. We're going to need to start to evaluate it and look at things as to see what we have to model our surface. Now, there's one other use for a break line, and that is an exterior boundary. So if you look at this area right in here, and likewise this area down in here, right now there's nothing in our drawing that says when I get on this, and this is how it models. It goes to every point, every vertex, everything with 3D information, and it sits on that point and it looks around itself 360 degrees. And it tries to draw a connection from that point, say, up to any free point that it finds. There's nothing in the way, and it will form a triangle edge there. Once that's drawn in memory, then that keeps, say, from this point from being able to look across it up to this point. But if it's not drawn yet, it can do that. All right, now, I look at that and I see, can you see these, all these little points, these little purple dots? They're just CAD points, but they're part of the data set that we would use to model this. So this point right here on this polyline is free to form a triangle edge up to this one. It can also form a triangle edge up to this one, or it could go up to this one, or even up to this one, unless something else forms in its way first. Okay, so in this particular example, the line that goes from, say, here up to here, and let me draw those in for you. If I go from, say, this point to, let me turn this on, node, which is a point. So if I go from there to, say, this point, then that could form a triangle like this, saying that that is a planar configuration. However, if I look at, and I'm going to, let me turn these on, I'm going to points, I'm sorry, the settings menu, and I'm going to choose this IntelliCAD settings, and I'm going to choose point styles, and I'm going to change the points so that you can see them a little better. I'll make them look like X's. There you go. So I could have formed this triangle. However, if I had done this like this, say from this point up to this point, and then over to this point, and then back. Now, those two particular triangles, if I look at them in my 3D viewer, see how the green one is actually over top of that yellow one there a little bit? Let me give it an exaggeration. All right, so you see how the green triangle is actually sitting up higher than the yellow triangle. However, with nothing in the way there, either one of those is free to form the way the other one forms. Now, the good thing is that once one of them forms, like let's say the green one forms first, then this yellow one is not able to sit here and look over here and find this point. All right. Now, the good thing about having points along some density like this is that it is unlikely for this green one to form first. It's more likely that this yellow one will form first because it looks at the distance between the points and tries to use the shortest one. So there are some, excuse me, there are some controls that sort of happen along the way that will prevent that. Now, if you happen to know what that is, for instance, if I know that, you know, this is say an edge all the way down to here, and then this is an edge, then I would need to come in here and pre-draw, say from here to here, to here, to here, to here, and then maybe draw another one, say from here to here, to here, to here, to here, and to here. Before I do the modeling, what that does is it keeps points on this line, and it keeps these points over here, and say this line. It prevents this point from looking across those lines and finding these other points. That can only go to the points it can see. So that can go up to here, down to here, down to here. So it can look along the lines, it just can't cross them. It can also look backwards and find this one, this one, this one, anything on this line back here, unless something is in the way. Okay. That's what we have to learn to recognize is we have to draw these edges in that represent physical edges in our actual data, in the actual shape of the data. So if this is a bunch of surveyed points, and if they're actually the edges of a sidewalk or pavement or something, then we need to draw that in ahead of time. Now, the white lines that were drawn that you're looking at here were actually compiled photogrammetrically. And so they were put in there. The guys looked at the model and they said, okay, that's an edge. So I'm going to draw that edge in all the way around. And you can see they followed the edges of the roads, the center lines, the ditch center lines, that sort of stuff. Now, what about if you don't have those white lines compiled? Oh, I'm sorry. I meant to do this. So let's say we didn't have those. Now these lines down here are just 2D with no elevation. So they don't count as break lines. They have to have elevation. So what does that mean? For instance, on these particular, if I use this data to build the surface, well, these become the source of those points. And if I'm sitting at this point and it looks across here and connects these two lines, well, that's a valid assumption. It goes from that elevation to that elevation. It goes from this elevation to this elevation. And those are all pretty valid. But what happens in a case like right around these ditches and edges? When I get up here and I can look across and see these other points, they're valid. But when I get over here, if I look across and see that point, what's this elevation compared to that elevation? They're equal, aren't they? So it says that because it's all along the same contour line. So if I go from this elevation to that elevation, this elevation, say to this elevation down here, so that's going to say everything in between is all going to be that same elevation. And that's incorrect because the elevation right in here is, when we know from looking at it, that it goes from here up to here. And it does not go from here over to here. It's not the same, because if I walk this line in reality, I'm going to come down till I get to the elevation down here, which is actually lower than this elevation. And then it climbs back up. So I have to draw that edge in there along those elevated lines and say, you can't cross that, because otherwise I'm going to get my ditch line here looking like a set of stairs. It's going to come down, hit that elevation, and then it's going to go flat from here up to here, and then it's going to drop down to here, and then it's going to go flat up to, say, about in here, where it might cross, where this line might form across in here. Okay, so let's take a look at what happens if we do that? Let's go to the surface menu and let's choose triangulate and contour. And let's go to the triangulate tab and let's turn on the right triangulation file and let's hit the select button and let's just give it a name. I'm going to again go back to that old file called EG that I did yesterday and say save. Yes, I'll write it. Now, I'm going to uncheck this use inclusion and exclusion. I'm going to say shrink wrap. I'm going to leave that to none for right now. And I'm going to ignore my zeros. So that's another thing that we typically leave on. Okay. Otherwise, it will drop down and try to make an elevation down along things that are at zero elevation. And let's go to the contour tab. Make sure that's unchecked so that we don't draw the contours. I don't want to get into a bunch of screen mess right now. I just want to show you the surfaces. All right. So now let's make this surface and we're going to choose some of this data to make a surface from. We're going to say, okay. And it's going to now prompt me to select entities, but read the line above it. It says select the points and break lines you want to triangulate. So I'm just going to look at a few here along this roadway. I'll maybe come over here to the right. I'm going to click once in empty space, and then I'm going to drag down into the left and click down here. And I'm going to get these now. It's going to pick up all of these because I crossed those. And that's okay. That'll be what I use. It's just going to be a part of this surface. I'm finished selecting, so I say okay. It's going to create. Let me go back to. Let me repeat this and show you where that message is coming up. It's saying the maximum edge length, interior 2000. Let's set these both to 2000. That way I won't get that message for right now. Okay. And I'm going to say, come up here and go down to there. All right, so now it's built the surface. See, it comes back and it says writing the file eg.tin. So let's look at what happened with that file. I'm going to go to the view menu and choose 3D view surface file viewer. And it's going to prompt me to choose a file. I'm going to choose that file we just built and I'm going to open it and it's going to pop up into our viewer. And now this is a resizable floatable window. I'm going to double click the title bar so it zooms up to full size. And I'm going to see if I can't interpret some things about what our data built. Okay. So I'm going to go to my settings tab in this viewer. I'm going to turn off the display triangle edges. And now I'm going to go back to my view control and I'm going to take a look at this surface right in this area that I wanted to illustrate this point. So this little thing here is the light source. You can set it as if it's, you know, down and to the right. You think about that as the sun in the sky. And just as a general psychological note, we are conditioned through advertising and all kinds of other things where we see 3D objects printed on flat paper we generally cast our shadows down and to the right. So the sun needs to be up and to the left. And that way you see how the road looks like it's sunken. And you can see down here, if I pull it this way, it looks like it's raised up and that this is sunken. But that's because, you know, that's just a conditioning of our perception. Okay, the data is not changing. All right, so there is what we're going to look at. And now, if we look at the cursor, this is going to be how we control how we view things. This particular icon, the little three-colored cube and the circular arrow around it, that is our main control to control what we view. And we can use that icon and we move the cursor into our data set. You notice it changes from a Z with an arc arrow to an X and Y with an up and down and left and right arrow. And that means if we were to press and hold the mouse down and move it, when it's in those particular configurations, it's going to do that type of movement. So what you want to do is, and you can, you know, play around and see that you can get all kinds of motion to it. But if you'll remember this little memory trick, when you're looking at this, when you first come into it, it's in plan view, okay? Think about or visualize to yourself that you're looking at your garage door on your house. And it's one of those doors that are solid. It doesn't have the joints in it. And when you raise it up, you're going to pick it up from a handle down here and you're going to pull it up and it's just going to lay back into the ceiling as a single unit, okay? So we put the cursor over the data, and this is general. You see how it switches right there? That's because it's finding down here where it switches. So it's not exactly on the edges of that, but in general, we want to be over the data itself to where it's X and Y, and we're going to come down toward the bottom of it, and we're going to click and hold. So you're going to be standing in your driveway, and you're going to open your garage door. So you're going to click and hold, and you're going to push it up. And you see how it rolls up into the ceiling? Okay. Now, once you get it up, laid back at an angle, then you can take the cursor, let the mouse up, take the cursor down to the bottom and click and move it back and forth. So it rolls about that location. So if I rolled it up there and I'm going to spin it around here, and now I want to look along what should be a nice clean ditch line, you can see how these triangles formed incorrectly. Now, right in here, they formed pretty correctly, right? So it just lucked out that it didn't wind up putting these stair steps in over here because of the point proximity. They worked out, they selected okay. Same thing in this area down here. Those selected okay, but these have a problem. All right, and if we look at that, I'm going to put this back into plan view by clicking this icon over here on the lower right. And now I'll make sure I'm back into my controller. I'm going to go to the settings tab again, and I'm going to say display the contours. Now that's just going to draw the contours that it calculated. It's not the ones that are in the drawing, even though that's what we use for our data. You can set the interval. I'm going to leave it at 1 foot, and I'm going to come down here and I'm going to see these contours. You see the original contour, let me change to this pointer, came along this. So this is all correct in here. It came down here and it really went all the way up to here and then came back down to here. But it says, no, I'm going to find that point and I'm going to make that flat. So that line is actually not supposed to be there. Okay, now watch what happens to this if while I'm using this, if I switch to this arrow. And I'm going to come down below and I'm going to do some 10 edits. I'm going to now add the break line. So the break line I should have added went from this point to this point to this point. So if I come down here to that point and I double click it.
Hey, Ken,
Yeah,
wouldn't you basically just want a break line following the entire edge from like where it's light green versus the dark green?
yeah. And if we surveyed this in the field, we would have surveyed this and said, draw the lines between these points.
Yeah.
Okay, but I'm saying if we didn't have that, if all we had were those original contours and we tried to build a surface from those contours, if we don't draw that line, it's going to come up with these errors. So here's what we would do is we would add this break line, say from here to here, and see how that now fixed that. And then we'd also do it from this point down to this point. Okay, so you see what I'm doing is I'm artificially placing, or not artificially, but I'm placing break lines between the points where they really should be. And that's really defining that edge. Okay, and then I could go through here and, fix all of these individually after the fact. Well, that can be quite tedious if you've got a large site. Well, I fixed that side. I could do the same thing over here and go from, let's see, so that came across there. So right here's my point to point, and see how that pulls that back up where it's supposed to go. Same thing from here to here. and from here to here. And we would do that all the way down our site. And here's another instance right in here where I would need to go from, let me see exactly where those. I would go from, say, here to, oh, wait a minute, let's go from here to here. Let's see, I need to get rid of that little dot. So going from there to there, and that'll pick that up. Maybe only from here to here. It's not. So then maybe I need to, let's come back to this. Let's remove that point. So if I remove that point, and then that point, then it's going to recreate that. So, you know, you can see it can really get into a nightmare if I'm trying to prevent these contours from going across those flat areas. So I might, you know, add a break line, say from here down to here. So now that picked that up, and we turn these triangles back off so you can see. So that flattened that part out. You know, so that can be quite tedious to have to try to come in here and fix all of those little areas, when the easiest way to do that, instead of doing this segment by segment, is to draw. I'm going to go ahead now and exit our viewer. Since I've made edit, it wants to know if I want to save changes. I'm going to say no. And so now to fix this, let me go back to, I'm going to, let's restore all the layers. And I'm going to just isolate my layers. I'm going to go to view, isolate layer. I'm going to pick one of these intermediate contours, one of the index contours, and say, okay. So now this is really all I'm going to use. And there you can already see it might form a triangle across here. In fact, probably will, when I really need to have this line from this point up to this point drawn to keep that from happening. Okay. So you would, if this were the only data you had to build your surface from, you need to go through and create these individual, let me make this a contrast so we don't use. So you would go from, say, this point down to this point, and I'm snapping to those points to prevent that from happening. And let's just add a couple more here. And that'll be enough to illustrate the point. I would do the same thing again from, say, here up to here to here to here and to here. Follow that feature all the way down. Now, again, the surveyors or the aerial compilers would be the ones that would normally do that. Okay. I'll repeat it again. And start back here on this one. We put this in like so. So that'll be enough there. And you can see now if I use these, this line here will prevent this point over here from looking across and seeing this point and making that flat. It now knows it has to go from here. It can go down to points along this line, and there aren't any except for up here. So it would form all the way down there and come back up. And that would be more representative of that edge. Same thing, I would do it over here on our opposite side. Say from here to here to here, and I would get all of these edges as I go along. Okay. Repeat it, and then we need to get the other edge, which is from here to here to here to here to here, and to here. One more. And I would do it again. Let's say here, well, let me do it from here to here, back to here, and you're going to see when this forms, it's going to look like a sidewalk. Oops. So let's go from that edge to 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 that edge. Finally up to here. And let's tie it off back to there. Okay, so now I've got a bunch of lines that have elevation based on snapping to these corners. And in fact, if I look at that in my 3D viewer, just at the data, not at the surface, we haven't built it yet, you can see that I've actually gone through here and laid those lines in right where they need to go. See, in fact, this one here needed to have gone on up, but we stopped it a little short. All right, so now let's take a look at what that forms. We're going to go back to surface, triangulate and contour, and leave everything just like we had it. We'll say okay and yes to overwrite the file. And now we're going to get that same little clip of data. And it built the file. I'll now go back to my view, 3D view, surface file viewer, load up my surface file, go to my settings, turn off the contour just so I can see it by shape better. I'm going to roll that up, go around, then I'm going to use the wheel on my mouse and just zoom in, and you see what a nice crisp edge it forms there, and that little dip in the median. And now look over here on where you can see this sidewalk has come up to form that flattened area with that curve that jumps up from that edge to edge. Okay, so that is what
Hey,
you would.
Ken, it's telling me when I go to triangulate and contour, it's telling me that my polylines are not closed.
Okay, so what it's doing is it's asking for, when you go to surface, triangulate and contour, you probably has this use inclusion, exclusion area is still checked.
So uncheck that.
Go ahead and
It was
run.
checked.
Yeah, uncheck that, because what it's asking you for is, if you have it checked, I'll go ahead and do that and say, okay. What it's asking you for, it says select the entities, and if you just cross it, it's not asking for the data yet. It's asking for you to select entities, but it says select the inclusion parameter or hit enter for none. So I'm going to hit enter for none, and now it asks for the exclusion or enter for none. I have none. Now it asks you again to select entities, but now you're selecting what you're going to triangulate. And at that point, you can come across and grab that data. Okay. Or when you run the command, uncheck that so you're not prompted for that. So always when it says select entities, read the line above it to see what it's asking you to select. Okay. So now when you view that surface, it should look like that, and you will have taken advantage of those break lines that you drew in up to where you quit drawing them in. You can see right in here, that comes into a bad point. And if we just added a break line, say from here to here, see, it fixed that. All right, so, but the thing is, we want to fix it before we build the surface. That's why we actually, took the effort to put these in. Now, if we have that to have to do, there is a sort of a shortened way that we can do it. If we look at this, for instance, if I want to connect all of these valley points, say here to here to here to here to here, And if I go around a curve, watch what happens. If I just do a 3D polyline again, if I go from say here to here to here to here to here, and I'm coming around the curve to here to here. Now what happens right here? See, I've got a 3D line that goes from this elevation straight down to this elevation. And I'm saying it changes linearly down that line, but really it should pick up this elevation right here. But I crossed it. That's going to give me an error called a crossing break line. And so the way around that would be that if I were to take this line, I would need to sort of, you know, add these, you know, I need to make my line sort of go around the curve to avoid that crossing. But when I do that, I don't have any elevation out here to know what that is, okay? And I could go back and edit the line, et cetera, et cetera. But there's a trick I want to show you that can help you do stuff like that. If you draw these in first as 2D polylines, and here's the reason why I want to do that is because we can add some arcs to turn those into 2D polylines. So if I draw a 2D polyline, and we'll make this one yellow just to keep it clear in our minds which we're doing. I'm going to just click here and I'm going to go to each of these key points. And I'm not going to care right now if I cross something like right here, I'm going to cross that, okay, and go here to here to here. Now, once that's done, I look at this and I say, oh, I crossed there, so I need to fix that. So I'm going to select this and I can either add a vertex and just keep, you know, clicking my way around, or I could even just turn in to, I'm going to hover the mouse over the midpoint. You see, it's a smaller grip. And I'm going to say convert to arc, and I could, you know, say press it out like this. Actually, I need to move that down to there. And, you know, I would, you know, want to try to make it as smooth as I could make it as it goes around there. So I'm not going to take the effort to do that at this point. But now, so this is still a 2D polyline, but how do we turn that into a 3D polyline is the next question. And turn it into a 3D polyline that reads the elevation of these things that it crosses so that it picks up that contours elevation right at that point. Okay. And even if we take out a particular vertex, even if we didn't snap to all of those, let's say we do something like this. We draw a 2D poly and we go from, say, this point all the way up to this point, right? Now, I can fix that by taking this polyline, and let's say I convert that to an arc, and I pull it out here a ways. All right, now I'm still crossing in here, so I'm going to come here and maybe say add a vertex. I'm going to get outside of that little structure in there, okay? Now, obviously, I would need to come back to these corners, but you see, I can reshape these turn that back into a line. And all right, so that would work in there. And then I would maybe convert that to a line. Yeah, that would work there. Now, so I can reshape this pretty nicely. Let's get outside of this area now, convert this back to a line. All right, so I've missed that crossing, so I've set that up, you know, correctly. But I didn't really snap necessarily to those corners. But how do I read when it crosses this contour line? It needs to set the elevation of this yellow line to that exact elevation of that green line that it crosses. And that's a tool that we're not going to have in survey. I don't think. Let me see if it's down here. No, all right, so that's going to be one that the civil menus are going to give us the tools to do. And so I'm going to go to my settings menu, Carlson menus, and I'm going to switch to my civil menu. And this has to do with 3D data. So I'm going to say, go to my 3D data menu, and I'm going to convert that 2D to a 3D polyline. And I want to do it by screen entities. So it's going to read all of the screen entities that it crosses and read those elevation points and set them along that line. So I'm going to say by screen entities, and I'm going to say, you know, I can extend the intersections a little bit if I want. I can ignore zeros. Extrapolate the end. So if I ended out in space, I would extrapolate the end point. So as it crossed it, it would keep the same slope until it ended. I could keep the existing polylines. I'm not going to need to. I'm going to put them up on a particular layer and then say, or let's just leave it at that and say, okay. Select entities, but read the line above. Select the polylines to convert. I'm going to convert that one. I'm through selecting, so I hit enter. Now select the surfaces, lines, and polylines that I want to use to read. I'm just going to grab all of these things in here. Even if it doesn't cross them, they'll ignore them. And so now it has taken this and placed elevations everywhere it crossed one of those. And then in here, you see it crossed here and it crossed here, but because it went around this shape, it had to put in those little segments and it set the elevations just as a straight line interpolation from this elevation to this elevation, and then all the way down to here as well. Okay. So now if I look at that particular set of data that I just manipulated, you can see, in fact, it did read the elevations of those green lines and it raised it up so that it followed along the shape of those edges. Okay. So that is a technique to draw those in fairly quickly, draw them in as 2Ds, connect up the edges, make sure you don't cross things, and then set the elevations based on these things that it's going to cross. And that's under 3D data, 2D to 3D polyline. Okay. Let me see. There's 3D to 2D. We don't have anything else. Available in survey. I was just trying to see. Yeah, we don't. So again, if all we had was this contour map to build a surface from, we have to draw all these things in manually, which would be a good bit of work. Or there's one other technique, and I'm going to right now, let's, I'm going to isolate this layer again so I can delete, or actually I'm not going to isolate. I think this is on layer 3D break line. This is on layer boundary 2. So those will be the only things on those layers. I'm going to go to edit, erase, and I'm going to erase by layer. And I'm going to just leave all checked. So everything that are on the layers that I tell it, I can either select them by name or select them from the screen. So I'm going to select from the screen. I'll pick one on, you know, one representative sample on each of those layers. I hit enter, it fills out the layer list. I hit OK. It now has cleared those out. So now they're gone. All right, now there is a little helper technique when we model. We go back to the surface menu, which is in a slightly different location here at civil. But you see that triangulate and contour is in there. So I choose that. And I'll leave everything like it was, except I'm going to uncheck this inclusion exclusion, so I'm not prompted for those. I'll say, okay, yes, okay to override. Oops, sorry. But let me escape that and try it one more time. I want to show you the little helper. So I'm going to uncheck that use inclusion exclusion, but look down here at this block, right here. It says adjustments for when your source data is contours. if I interpolate ridges and valleys, maybe, well, that one actually doesn't work as well. I want to minimize flat triangles. So you remember what happened when we didn't have the break lines, and it jumped across those V-shaped contours and made those little flat areas? If I say minimize the flat triangles, it's going to do its best to try to minimize that. So I'm going to say, okay. And I'm just going to grab, that same type of data. And remember, there's no break lines in it now. And I'll say, okay, it builds my surface. I go back to view it, and look what's happened. Is that it has at least partially done that. It went through there and it found some flat triangles and it got rid of them. Okay, so it took it upon itself to make that decision, but I still have some things over here that it didn't quite catch. Okay, but it's still much better in that regard. So sometimes if you have just a bunch of contours is all you have, you don't have a lot of time, you're going to want to turn that switch on to says minimize flats. Okay, so that's a little helper that you can get by without having to draw all of those in there. Now, luckily for us, we have all of that data in those lines that we froze off. Those were the break lines that they compiled, and that's really all we need. We don't need these contours, because the contours that they drew into this file and showed us, they actually are the result of them looking at those break lines and building the surface, and they just drew them in there for us as where those contours are going to go. We can do the same thing when we model with the break lines and we say draw our own contours. And we'll do that here in just a second. But one of the things I wanted to show you, let's go back to this surface file menu, and we're going to triangulate and contour, and let's now uncheck that minimize flat. Make sure our contours are not drawn. So we're going to just have what we did before, where we will get those flats. We'll say, okay, yes, okay to overwrite. I'm going to grab this data and go. It builds the surface. It doesn't give us any errors. And you may be tempted to say, oh, great, I've now got an existing surface. I can use it. Well, here's, as you saw when you viewed the surface, you're going to have all of these flats down here. And so they're not accurate, right? It's close enough if you're just doing bulk earthwork type movements and you're comparing one surface to another in this regard. So what I want to take a look at is the surface along that line. And that's going to be with this command. It's on the profile menu, and it's called a, and I think it should be looking for quick. Oh, it's up here at the very top, a quick profile. If I go back to survey, let's go back to survey and look at the profile menu. I've got center lines. I don't have a profile menu, but under surface, I have that command right here called quick profile. Okay, so I'm going to look at a profile of my data. Now, if I look at the source for that profile as being screen entities, things that are drawn, ignore 0, and I say okay. And it wants me to pick a starting point or use a center line or a polyline. Well, I'm just going to pick this point, say right here. I'm going to pick a point here, and where am I going to go? I'm going to go down to right in here. Okay. So I didn't follow along it, but it's sort of close. Now, if I look at it like that, it looks okay. It looks nice and smooth as it goes down along that line. Okay, but I'm going to say exit to that. And if I repeat that command, quick profile, and if I, instead of using screen entities, if I use a surface file, now I can compare two different surfaces at the same time. If you've got two names in here, let's just hit the second button and hit cancel. So it clears that out. And the first file, you see that's left over from the last time I ran the command. I'm going to click the first button and I'm going to get the file we just built. I'm going to say open. I'm going to say okay. And now it wants to know the line I want to look along. So I'm going to go from here down this ditch like this. Click in there. And now you see what it does. So now you can see where those flats are coming up, you know, where they got created in the surface. So the reality is that the line should have started up here where I started and come down to this point right here. And I'm looking, say, here in this profile view. If I start up here at this elevation, it should come straight down and not flat, but straight down to that point. And look at the profile, watch the crosshairs. And then it should go from that straight line down to that point without going through all these stair steps. Okay, same thing, it should go from, say, right in there down to right there without going across that little vertical step. So it should look the way you saw it a minute ago. And this is another way of evaluating this data that gives you an indication that it's incorrect. Okay. So you won't have to do this all the time because you're going to know the technique is you want to make sure you have the break lines defined. Okay. So that's just another way of looking at our data. Now, let's go back to the original data and let's restore the layers so everything's back on, and let's now freeze the contours. So I'm going to freeze layers by pick. And I'm going to zoom in here. I'm going to pick on one of the intermediates and then one of the the index contours. I'm also going to do the thing for these little dashed lines because those are in the obscured areas. So now all of my contours are off and I've only got all of this 3D data that consists of break lines and points. You see all the pink colored points. Those are points that they put in the file. And I've got all the edges defined. That's my break lines. All of this other stuff is just for cartographic purposes. They're drawn down at 2D, 0 elevation, and they have no elevation information. If I look at that island up there in its 3D location, I see I've got those lines and they're elevated. And what we looked at yesterday, if I go to my surface quick profile, I'm going to use screen entities this time. I'll say, okay, and I'm just going to come across that curb island. And now I can see, you know, I'm exaggerated here. If I take my exaggeration out, it's nice and flat, but let's do a little 2-time evaluation. You can see right in here as I cross that raised island, you see see here in the profile how it comes down. And then let me click up here and zoom in. So now as I come here, I hit the back of the curb and it comes down to the face of the curb. That is that triangular wedge curb that I was telling you that is probably in there. But if we know it's a vertical faced curb, I need to have the line that's right above this one to show up. All right, so that would be a case of what we did yesterday. We're going to create that line based on the reference to this line. And we're going to do that with a 3D offset because we want to offset this line just a wee bit back. We can't have a vertical face. So we want to go just a wee bit back, lay it back just a little bit, but raise it up 1/2 foot. So I'm going to go to my edit menu, 3D polyline utilities, and I'm going to offset a 3D polyline. And I'm going to use this method, and you can look those up later, what these various ones do. And some are pretty sophisticated, but I'm just going to use this interval. That's the one we use most often. Say, okay, and it's going to prompt you to choose the horizontal offset amount. And I'm going to type in just 0.0 500s, just barely off that line. That's how far I'm going to go horizontally. And then vertical offset amount, and you can do it by a percent grade or a degree or a ratio or a vertical amount is my default. So I'm going to raise it up a half a foot. Hit enter. I'm going to pick the line that's down here on the face of curb and make sure I get the 3D poly on it. And I'm going to set this side. It asked me which side to offset. I'm going to pick on that side. And now I finish the command. I see I now have that line drawn for that one. And let's go back and look now at the quick profile. Same thing, screen entities. I'm just going to drag across the same thing we did before. And I'm going to see, let's put our 2-time vertical exaggeration. And as we come up to this area here, I can see down here in my profile, I come across, let's zoom up here a little better. So I get to right in here where my crosshairs are. I'm on the back of the curve and I come all the way out here to where it gets ready to drop. And you see I'm on that line that we offset. Let's zoom in a little tighter. So I'm now right there. I get to the offset line, and then when it drops down to the face of curve, you see it makes that near vertical drop in the profile. Okay, I come up onto this side now. Back over to here where I look. And I see that that's still now laid back as that wedge curve. Okay, because we did not do that same treatment over here. So sometimes, and again, you have to know what is actually out there on the ground. Is it a true wedge curve? In which case, this line we don't need. And I believe it is. But if you know that it's a vertical curve, sometimes you have to add some data to it to model correctly. Okay. So, but now we have all the data that we want to model. Let's go ahead and build this surface and take a look at it. So let's go back to the surface menu and choose triangulate and contour once again. We're going to write the file. It still says EG, so it'll ask us to overwrite. That'll be fine. We'll leave everything like we had it. Make sure we uncheck the minimize flats because now we're using all of the actual data and not the contours. So we're not making any adjustments for using contours. And we'll say, okay. Yes, it's okay to overwrite. And now it says select entities. I read the line above. It says select the stuff you want to triangulate. Well, I can draw a window around it and select it, or I can type ALL and hit enter and enter to finish. And it builds the surface. Now there's a couple of little places in here where you get some crossings. And it has to do with this head wall around this culvert, and they just compiled it wrong. That's an error in the data. We're not going to take the time to try to troubleshoot that. We would just know that we need to fix that. Okay. So it goes ahead and makes some assumptions and takes care of that when it models the surface. Now let's look at this surface. View, 3D view, surface file viewer. And it will be the entire site. And I didn't have to draw any of those break lines in. You see how they're already accommodated all the way down that little sidewalk edge on this side, all the way down the nice ditch line on that side, including up here to pick up the curbs. So everything is exactly the way I want to see it. Okay, with some possible errors to think about. Look over here. If I turn on, I'm going to click this button here on and off. That means color in the faces or open them up. So what happened over here? Why do I have what looks like surface over here? And if you remember, when we go to build a surface, it sits on each and every point it finds and looks around itself in 360 degrees and tries to find other points. So a point right in here, for instance, this point, looks around itself and it finds, say, you know, this point and this point and this point and this point. Those are all good, but it also looks up here and it goes all the way up here to where it comes out to it sees that point as well. So it starts building these triangles, but we don't really know anything about that area, do we? That's not in our real data. It's clipped out of our data set. So we could do things like, remove a triangle, and we could, start removing these individual triangles. Okay, that would be tedious. We would not want to do that. We've got some other tools, as you might imagine, coming up. So if we did and then turned our surface back on, you see where I've removed those triangles. And it would take me, all day to try to sit there and get rid of these as I go along with stuff. All right, so I'm not going to do that. I'm going to exit that. I'm going to say, no, I don't want to do it. So how would I keep a point here on the end of this line from looking up here and seeing this point up here? What do I need in between those 2 points? Any guesses? What keeps a point from looking across and seeing another point?
A break line,
Break
3D
line.
polyline.
Exactly. And it doesn't, and in this particular special case, it doesn't even have to be 3D, because what I'm going to do is create a special polyline. It can be 3D, it doesn't have to be. But I'm going to make, and oh, by the way, if I looked at that surface, I'd see these long, skinny triangles down here as well. Show you that real quick. So you see these triangles all down here on this bottom edge. Okay, that's because it found some points and looked all the way across and found the other points. And you can see it sort of made it into like a little, like almost like a wall in there. All right, so those are invalid, but how do I keep those from happening? Is I need a boundary or a break line, a barrier to keep the points down here from looking all the way up into here and finding these other points. And that's going to be done by establishing an overall exterior boundary that we're going to say, only look at the stuff inside of this location, okay? And so there's several ways we can do that. One is we can simply draw a polyline. In this case, it will be a 2-dimensional polyline. And I'm going to just sort of eyeball my way around up here and just click, click, click. And close that back. And that's now, make sure that is closed. So that now would say, don't allow yourself to say a point on the inside of this cannot look up here and see another point as long as it's on the other side of that line. Okay. So if I go back to my surface menu, triangulate and contour, and what this switch is, and this is where you were running into this a minute ago, Robbie or Joe, whichever, forget who had the problem. We're going to use these inclusion and exclusion areas. So it's going to ask us to show it what we want to use to include. And the different method is we're going to typically just trim the edges instead of removing the entire triangle. We're going to stop the triangle at the edge. We'll say, okay, we'll say, hit overwrite. And now reading your prompts, before we just gone and grabbed our data. But it says select entities, but it says select the inclusion perimeter polylines, and it can be plural. So I can have, part of it here and part of it over here. But in this case, it's just the one. So I'm going to select this as my inclusion. I'm through selecting inclusions. I hit enter. It now asks me to select any exclusions. Examples of those might be buildings that you don't know what the ground looks like under it, or say a pond because you don't know the shape of the ground under the water surface, for instance. But we don't have any here in our example, so we'll just hit enter for none. And now select everything we want to triangulate and type the word all or draw a window around it. It's going to give me that same error box. I'm going to exit that. And I'll now look at my 3D surface again. And you'll see that it has trimmed out Now, I still got a couple of little goofy spots in there, you see. See right in there. So I need to have that a little more well-defined, but I don't have to do anything to it other than draw that line. Now, if I see in here, these are probably not valid. Okay, you see how they sort of form this goofy looking thing in here. So you could go through here and say, tighten this up, maybe, add a vertex in here, add a vertex in here to sort of do something like that. Or you could say, well, that got pretty much everything here. I don't really need everything out on the perimeter. I'm going to just offset that to the inside a little bit. So if I edit offset, and this will be a standard offset, it's not a 3D polyline, just a standard 2D offset. And I need to show it a distance. So I'm going to maybe say go from here to say in here a little ways. And then I'll pick this guy. Hold on a second. That again. All right. So the distance will be, I need to not snap. Let's just say I'm going to go from here to there. Now I'll pick this guy and go to the inside. Now I could say get rid of this one. Repeat my surface triangulation. Pick my inclusion, no exclusions, grab my data. And now when I get this and look at my surface, I see that I've, shaved off those areas over here on this edge that on the bottom edge. Same thing up here on the right. I'm inside all of my data, so everything looks pretty good up there. Now, there's that raised planter, but you see my inclusion area. Let's go back and look at it. You see, it stops right there, so it doesn't consider any of this data out here. But so what if you wanted to get everything, but make sure you got it all instead of trying to worry about fine-tuning that polyline? Well, there's a command, and it's available in a couple of places. One is if I could take all of this data and shrink wrap it, right? Wouldn't that sort of, vacuum in all of the edges up to the surroundings, okay? So I'm going to draw that shrink wrap boundary, and it looks like a little birthday gift here. Shrink wrap the entities. And I'm going to allow it to go across the gap. So I want it to be able to span this gap. I don't want it to have to go around and find only the edges of the line. So I'm going to go across the gap. And I can give it a maximum gap to use, for instance, that sort of stuff. And I've got this setting here for perimeter reduction. I'll show you the different effects. If I say none, I'm going to make it a 2D polyline. I'm going to say, okay. Let's say I'll even ignore zeros and I'll say, okay. And now it says, select the points and lines that you want to shrink wrap. Well, it's everything. And I'll hit enter, and there it is. Now, it's sort of done. You can see it comes around the corner here, but look up in here. If I use that as my boundary, I'm still going to get the triangles in here. I'll still get some of these triangles in here. It followed pretty well where the data was okay, but it didn't come into there. But that was because of that none for the boundary reduction. Now you could, again, it's just a polyline. You could do something like, add polyline vertices, and you could just sort of, click your way around to sort of fine tune that itself directly. Or we could do this. I'm going to get rid of that one and do the command again to shrink wrap. So draw, or on our draw toolbar, it's the one that looks like the birthday gift right there, shrink wrap entities. I'll do the same thing, but instead of perimeter reduction of none, let's do it as high. I'm gonna say, okay, and I'm gonna grab all my data. Make sure I've got it all. And now if you look at the difference, well, it really jumps in here. So I go from this point and it jumps all the way in up to here and backed out and backed out. So in truth, though, you know, I might want to say, allow that to interpolate, because that keeps the edge a little straighter. You know, you could do that to sort of fine tune your way around it. And if you look up in here, see how it goes all the way around here. So you might want to maybe, you know, allow this to be there, and then we would remove all of these, you know, up to where we got to the edge. So you can do those kind of individual edits if you wanted to. Same thing here, remove those. All right, but bottom line is, when you use that command, you use shrink wrap. You notice in here, see, it's gone down here and found these points and things that it has followed. When we say a high perimeter reduction, what we're actually saying is, I want you to go ahead and build triangles for everything, and then look at all the triangles around the perimeter edges and start reducing those triangles. So when we said none, when we did the shrink wrap, it didn't reduce those at all, in which case that's why it came across that gap and came across up here and didn't reduce any of those long slivers. When we said high, it took a lot of those out, some of which we might have wanted to keep in there. So we find that, you know, probably a medium is their best option. And now you see it does snug up in here nicely, but it's not as severe. So down in here, you know, maybe that particular one you might remove out. But here's the other thing to consider. When you have all this data compiled and you're going to build a surface, maybe you're working, you know, right in here, and you're not really concerned about this kind of stuff. So I wouldn't waste my time to try to fine tune all that. It's not going to hurt anything to leave that as it is. Okay. So then when you do the modeling, again, surface, triangulate and contour, using the inclusion exclusion areas, say, okay, it's okay to right, we'll grab our inclusion, no more inclusions, no exclusions, type all. Oh, sorry. Missed a prompt here. So we use this inclusion, no further inclusion, no exclusions, and now all. And it built it, gave us their little error box. And we look at our surface one more time. Notice I keep looking at this surface. That's part of the evaluation that we're talking about. Now you see it's sort of crinkle cut around the edges, but everything that's within those edges is legitimate surface information. I get all of this stuff up here, even though the edges are a little ragged out here. All right. Now, the nature of photogrammetric compilation data is these guys always do this outside. They build the surface and then they bring the, if you look at the contour lines back, back on where they were, you see how their contour lines end right in there along that edge of that pavement. So that's really all the contours that they did. So they trim back the contours. You see, it's trimmed off a little bit. So they compile the data and then they trim off the contours so they're really good, valid information. So I'll now freeze those back. Okay, now, so that's what you could do. You could use shrink wrap to draw those boundaries, or you could just simply draw a polyline if you know where the boundaries are, or it's built into the command under surface. So I'm going to erase that boundary one more time. I'm going to run triangulate and contour one more time, but I'm going to uncheck this use inclusion exclusion areas, and this command will draw the shrink wrap perimeter itself. It will compute it. And right now I would say no perimeter reduction. So I would get that long over here. But if I say, you know, low to medium, let's use a low. And if I use the setup button, I can choose to draw a 2D or 3D. A 2D will work for a boundary, and I want to draw it. And I'm going to select it to be that boundary 2 layer. So it's that same one. I'll say okay. I'll say okay. And now it's not going to prompt me to pick the inclusion boundary because it's going to compute it for me. It just says select the points and break lines to triangulate. So I'll grab the data, let it go. It's going to compute, give me the error. And now you see where it went ahead and did that, just like we did before, except I used a low instead of medium. So maybe I want to, you know, bring that in like that, you know, tighten it up a little bit in there. But that's a nice way to where it goes through and creates that for us so we can see what it actually would look like in defining our boundary. And we look at that in our surface that just got built. And you can see it's not quite as choppy looking because I didn't reduce it quite as much, but it also doesn't include those long skinnies out in there and down in here. Okay. Now there's one further technique. If I do that, if I say surface, triangulate and contour, and I'm not going to use the inclusion exclusion areas. In fact, I'm going to put this back to none. So it would include these long triangles, but I'm going to come down here and put another control on here that says maximum edge length for exterior triangles. I'm going to say, don't make any exterior triangles bigger than 50 feet long. And if I say, okay, it's not going to ask me for anything other than my data to use. Here it is. And with the shrink wrapping, it would go ahead and draw that out here. But it says, okay, I skipped 158 edges because we went more than the 50-foot edge. Say, okay, I'll exit that. And now I look at my surface and I can see that it is actually trimmed up nice and neat up against those edges because it threw away any triangles along the edge, along the perimeter that were bigger than 50 feet. And if I, you know, show those edges, you can see, you know, some of these in here might still be a little bit invalid, but again, where you like, you might want to include this ground in here, but you know, safe to say when you're working on the site, you're not going to be right out there on the edge. And if you are, you're going to need more data out here anyway. All right, but you can see how that really modeled nicely. It picked up the thalweg of this pond, the stream going through this pond area, a little down channel from this perched pond. So, you know, everything is really the way we like it. We see up here, we've got that retaining wall that we looked at yesterday. See it on that loading dock? So everything modeled very nicely. That would be what we would then use for our existing ground. We would then design, and let's do a real quick design on top of this. Let's go to our surface menu and let's do a design pad. Wait a minute, let's cancel that for a minute. Let's draw the pad first. Just a 2D polyline. And I'm going to say, okay. And I'm going to say, maybe I'm going to put a building pad right in here, or maybe a parking lot or some kind of structure. And I'm going to type the letter C to close. That's one of my options at the bottom. So I now have a closed figure. Okay. And it is, you know, going to be at around the 13, 15 level, maybe. All right. So if I use that drawn closed polyline as a pad, Here's one of our tools under Surface, Design Pad Template. I'm going to use the source of my target to be a surface file. That's an existing ground I just built. And I'm going to go from this closed pad, I'm going to tie it into my existing ground to the outside. So it's going to either cut or fill out to the outward direction and make this at a particular elevation. Now, what if I said to the inside, what would that be? It would be along this edge and then it would go down to the inside to a particular elevation. And that would be like a pond or a borrow pit. But we're going to go to the outside. We'll treat it like a building pad. And I'm going to set my projection perpendicular to my slope direction. That's a little bit more conservative than the pad polyline. It's really kind of trivial in these little examples. And I'm going to come down here and all of these check boxes, I'm only going to have on my round, the exterior corners. I want to draw the side slope polylines and I want to color those. So they're going to be red for cut and blue for fill. I'm going to set my spacing to every 5 feet. I've got shrink and swell factors. I'm going to leave them at 1. And I've got a corner delta angle. So when I get around to this corner and it shoots points down here for the side, it's got to sweep around that corner to start putting these lines in. So I'm going to say just go every 10 degrees around that corner till you get to that edge to make that. You can make that as large or small as you want. And now down here where it says trim any existing contours inside the pad, I'm going to make sure that says no, because I'm going to leave the contours that they had drawn. I don't have any shown right now anyway. And you could, if you were, if you had checked up here to calculate the pad's surface, this would now be available that you could go ahead and draw the contours for that pad. But we're going to just create the data. We're not going to do all of that stuff in this one shot. You can, but we're going to leave it alone like that. And we'll say erase any previous pad entity. So if we change something, we can go back. We don't have to fiddle around with it. And we're going to call this pad layer. We're just going to call pad. And we're going to say, okay. All right. Following our prompts, it says, pick the pad polyline. There's the pad I drew. It's now at 0 elevation. Pick the target surface, that's the existing ground. And now it reads around it and it says, okay, loaded up my points and edges. I created so many triangles and it wants to know if I'm in fill, what kind of slope ratio do I want? I'm going to use a 3-to-1 fill. You can make that whatever you want. And if it's in cut, I'll also keep that as 3-to-1. And now it says, okay, but I don't know what elevation your pad is because it was drawn at 0. And it reads the existing ground and says the range of existing elevations along that shape goes from 1310.43 down to 13 or up to 1320.55 at its highest. And it wants a pad elevation. Now it suggests the lowest elevation that it reads just as a starting point. And let's say the pad is to be elevated all the way around it. So you might say something higher than 1310. So everywhere is going to be in fill, or you might say 1300 so that everything would be in cut, or let's just say a 1315. It's about, in between in the middle. So we hit enter. And there it is. It draws. Now it asks you if you want to adjust it and redesign it. At this point, we're going to say no. And it leaves us with that. Now, what has it done? All in the world that it did was draw this in as data. So if I take a look at this in my 3D viewer, I can see that, all right, there's all of the existing things, and you can see this pad it's set at that elevation that I gave it, that 1315, and then it drew in the features that would define that fill slope and that cut slope. All right, so what would I need to do to incorporate that into my site? That's going to be my future grade. Okay. Just like we built a surface out of all this existing information, let's now build a surface out of the pad information. And you can do that and sort of drive yourself crazy trying to select just those items, or let's go to view, isolate layers, and just pick one of these pad lines. Now that's all that's there. If I view this thing in my 3D viewer, you can see there it is. That's what will be used to model that particular building pad. Okay. So just like we did before, except a lot of this stuff has now been done for us. We've got all of this 3D data. We even have around here, we've got that inclusion boundary, so we don't get those long skinny triangles. So let's go to the surface menu, triangulate and contour. And this time where it says write the triangulation file, let's choose select, and let's give it a new name now called FG for final grade. Or you could have called it pad. In fact, let's call it pad instead of FG. Let's call it pad. And let's check back on to use the inclusion, exclusion areas because we have that drawn for us all automatically. I'm going to put this back up to 2000. Not that that's going to have any effect. I just want it there for the next time. So I'll say, okay, reading the prompt, select the entities, but read above it, select the inclusion perimeter. So there's that one. It happens to be 3D. It's fine. No more inclusions and no exclusions. And now select everything to triangulate. We're going to get this. We came up, built the surface, no errors. I can now build or view that surface, and you can see it gives you a little preview. And if I look at it in 3D, you can see how that looks. You can even, if you want to see the edges that got built, there they are. Notice there was no other points in the middle here because it's all flat in one element. So these long triangles are actually fairly valid because they're all the same elevation. That's no problem. Okay. If we want to see what the contours would look like, display the contours at 1 foot intervals, then that's what they would look like. They start down here, they climb up to 1 foot, they reach to that 1315. Now notice it's because it's an even foot that starts there. So if that interval was 2, you'd see it goes, 1312 to 1314. There's the flat elevation of 1315. So it doesn't have anything there to show on it. Okay, so that's a valid surface for just that particular item. Now, once we have that done, you could, let's go back to restore our layers now. We go to view, restore layers, which is right here or on the toolbar. So now we've drawn that, but we don't even really need to have that drawn. We could say, let's freeze the pad layer. And we were left with the original polyline that we drew it because it's on a different layer. But let's draw the contours for that into our drawing. Okay, and let's we'll turn back on the existing contours. Let's just put them all back on and then freeze these break lines. And I'm gonna freeze off these little existing points. I don't need them anymore to show. All right, so now I have my pad. I've got it drawn here, but I don't really want to see that in my final drawing. So I'm going to freeze the actual, all that 3D data. It's still there, it's just on a frozen layer. And now I want to draw the contours. I've already got the contours drawn for the existing ground. But if I go to my surface menu and I can choose to contour from a TIN file, this is why it's so important to save those files. Because once that file exists, I can generate contours from it anytime I want. So there's my pad. I'll say open. And you'll see it's a very similar box that you got when you ran triangulate and contour. But I'm going to go to my triangulate tab. I no longer need to be prompted for inclusion and exclusions. I don't need to do any densification. I'm just drawing contours. So I'm going to go to my contour tab and draw the contours. And I'll take the layer names that are there by default. I'm going to use a contour interval of 1. I will draw index contours at an interval of 5. I'm going to put no smoothing on. And I'm going to go to my labels tab now and say label the contours. Again, just taking the defaults, and I'm going to label the index contours only. Except I don't think I'll have any, so I'm going to uncheck that and we'll label them all. I'll hide the drawing under the labels. Again, it's going to create a wipeout for us. And then I'm going to come down here to either every so much distance, or in this case, I'm just going to say 1 label per contour. I'm going to say okay. And there they are. So 1310, and you can see they start right at the 1310. It comes around here and it ties right into those contours, just like you would expect to see that as a drawn element. Okay, I'm a little bit off the edge of my drawn contours, but my surface is actually defined out here. And just so you can see where the surface is defined too, you can also, on the surface menu down below here, you can draw. Let's see, I'm sorry, it's about in the middle here on the survey side. So I can draw the surface. If I just draw the boundary, I'm just going to draw the existing grade boundary. And there's where the surface is defined. So I'm still within that existing grade. I just had my original contours trimmed out here, so you don't see the tie right in here. It caught it here, but the original drawn contour got trimmed back, so that's all right. But you can see how it all ties in and fits. Okay. Now, how much dirt did we move to create that? So what would we need to look for? Type of earthwork, right? So let's go back to our surface menu, and we want to compute some volumes. And so we have a choice here. There's an option to use a 1 triangulation surface volume. So if you have, say, just a pond or something, or maybe even a stockpile, and you only have the 1 surface defined, then you're going to be asked to give it a reference elevation. So everything, computed above a particular elevation will give you that volume. But we have 2 surfaces, so we're going to use a 2 triangulation surface volume. And when this comes up, it's going to, the next one that comes up is going to look just like this. So don't be confused, but read this top stripe. It says select the existing surface. There's my existing grade. I'll say open. And it pops right back up and it says now select the final. So there's my pad. I'll say open. It asks me if I want to use any inclusions or exclusions. I don't need to, because the outside edge of the surface is as far as it will compute anyway. So I'm just going to hit enter. Same thing for the exclusions. I can put in shrink and swell factors. I can use cubic yards and square feet. If I want to do it, I could report tons. Let's say this was a stockpile of limestone. I might know that its dry density is 105 pounds per cubic foot. I could put that in and it would therefore tell me how many tons. I'm going to uncheck this writing the difference. And I'll say, okay. And now here comes the results of that calculation. That means when I build that pad, I'm going to have 2,600 yards of cut, 1,600 yards of fill. And right in here, in this area, is a pretty important bit of information that contractors typically have these numbers in their hip pocket and they know what this is going to give for them. It tells me that, all right, if I have to put that pad at that elevation, this is how I have to build it. But it says on an average, you're going to, and it computes that irregular shape as if it were a rectangular area. And it says, so on the average, you're going to have 2.3 feet of cut and 1.87 feet of fill at this ratio. And I'm going to have to carry off my site 960 yards. That's my export volume to build that. But if I wanted that to balance, it says I need to make an elevation change to make that balance of 0.475 feet. So I'd have to raise the elevation of that pad by just under half a foot, and it would balance. And now, obviously, there's all kinds of other considerations and constraints that you may have to go with. We may have to have it at that elevation, in which case we're just going to have to figure out where to put 960 yards of extra dirt. Okay, so it's telling us that, but it's also telling us for every 1/10 of a foot that we change it up and down, we're going to have 200 yards of volume. Okay, that's the number the contractor is going to have in his hip pocket. I was at a job up in upstate New York for Lockheed Martin. And the architect we were designing a new hangar facility for helicopters where they're going to fly in the president's helicopter and do all the super secret avionics and electronics and counter warfare stuff inside that building. So it's a pretty good sized facility. And it was all set, it was all pretty well balanced within certain reasonable limits. But the architect for Lockheed Martin says, oh, it sort of sits down in a hole here. And I want people to be able to see this new building that I designed as they're driving up the hill coming in the entrance road. So can we just raise the site up just a couple of feet? Let's say 2.5 feet. And the contractor said, yep, you can do that. It's going to cost you $5 million. And the architect had a little heart attack and says, what do you mean? I'm just raising it up 2 feet. Well, the contractor knows 2.5 feet, that's 25 of these tenths. So 25 times 0.1 is 2.5 feet. And then he knew this number right there. Every 1/10 of a foot change is going to require that much dirt. And he knew how much it cost him to haul a yard of dirt. So he just did a real quick calculation, said, yep, that'll be $5 million extra dollars. Because these numbers were obviously much bigger. And so the architect got a lesson in reality there. For his vanity was going to cost $5 million. And so it sort of took a back burner in levels of importance. But that gives you an idea of what you can come up with there. It gives you your total cut, your total fill, and then the spot, this X, Y location of where the maximum cut is and where the maximum fill is. Okay. So now, let's say you did want to balance that exactly. Well, we can do that, and you can have taken that. I'm going to go back to settings, or I'm sorry, inquiry, and I'm going to display my last report. I could say I could raise that raise the pad by that amount and rerun the computations and see if it gets me close. Remember, it's just averaging that as if it were a cube. So I could fine tune it that way over and over again, or when I do the pad design to begin with, I can tell it to, go ahead and set it to balance. All right. Or I've got some other tools over on the civil side. And since you guys all have civil, let me show you those real quick. So if let's get rid, I'm going to get rid of these contour lines. I'm going to go back to erase by layer again. Now it kept it from the last time I ran it. So I'm going to say clear for that. I'm going to select from screen. I'll select one of those contours, one of these labels, and one of those contours. And just in case it's on a different layer. And now say, okay. And so now they're gone. There's my original pad. Now in Survey, all I can do is design that pad right there and keep doing that as an iterative process. But if I switch, I go to settings to my Carlson menus, civil menu, it now loads up a different set of menus. And on the surface menu here, right under that same command, design pad, I've got an edit pad template. So if I choose that, it wants me to pick the pad polyline. Well, there it is. And it's going to load this up here. And it's going to say, here's my original design, 3:1, 3:1. There's the elevation. It didn't compute any volume. So if I run a report, for instance, just to get the, I'm sorry, I got to run process so that it draws, and there it turns those lines back on. That's the way we designed it at 1315. And the volumes say, well, there are 2,600 yards of cut and 1,666 yards of fill, or vice versa. I forget which one it was. But now, I can do the report, and there it is. So 2,600 yards of cut, 1,666 yards of fill. That was the same type of thing I did. All right, so now though, if I want to choose balance, I can balance that and watch what happens when it goes. I'm going to give it a tolerance of, to the nearest 10 cubic yards. And what are my target import and export? They don't have to be 0, because if I'm looking to get a particular number, like maybe I have to waste 500 yards from something else over here, I want to make my import to be 500 yards. But I'll leave them at 0, and I'm going to say, okay, now watch what happens. You see how that changed? It went to a little more fill, a little less cut, because it raised the elevation 1350. And look at that number, 0.4745. That was that just under half a foot that it raised to achieve balance. You look at my volume is now 2123 versus 2021, close enough for government work. It's within that 10-yard tolerance that I gave it here, okay? Now, the other nice thing about this editor is you can actually move the pad. Let's say, well, that's good, but I'm a little too far to the edge. I'm going to say, move the pad, just move it from, say, a point here. I'm going to move it a little closer into there. Now it's done, it's moved. All of the grading though stayed behind until I hit process. Now it recomputes what that grading would be. Maybe I don't like it there. I'm going to move it a little bit further off of that little slope bank up there, reprocess. That's a little better. And now my balance is still out of whack because I kept it at that elevation. So I'll choose balance. Say okay, and it will adjust the elevation to where now I've reached balance, 2092 versus 2087. Okay, I can now write the 10. That's my triangulated irregular network. That was the original pad. I'm going to just overwrite that one. I now have a new pad. I can now exit this. And by the way, you can change the corner points and rotate it and do all those different things. And so now if you contour that one, from surface, contour from a tin file from our pad, and we'll leave all of those things in there, draw the contours, do 1 foot, label 1 perp, so let's say okay. So now that would be the contours. I'm going to now freeze the cut and fill lines. And you can see now I tie the 1309, 1310, everything ties around. And it even, gets that little bump out there. So everything ties. And you can see even the 1320, it has to come down and start my cut to achieve that as a 13 or as a 3-to-1 slope. Now, do you remember when we said to try or contour from this tin file on our labels? We said right here, hide the drawing under the label. We're not going to break the contour, but we're going to hide it. And so because we did that, I'll cancel that. We have a really great tool that we can use now on the surface menus, and it's going to be to look at our contour labels. So I'm on the surface menu, contour labels, and I'm going to move the label along the contour. I select that and I just pick the label. Maybe this is too close to that and I want to just slide it down a little bit. So I'm going to grab that text and I'm going to move it to a different location. And maybe this one's the same way. Maybe even I'm going to go around the corner and notice how it walks that it walks around the contour, but it stays associated with that contour. Okay, so that's just a way you can, trim up these labels to sort of, make your drawing a little clearer. When you're done, you just hit enter. Okay. So just a couple of utility things that you can do. Now we've got 2 surfaces, existing ground, future grade, existing grade, future grade. We've even contoured our future grade. But what if we needed another surface now that incorporated the existing ground but had this pad built into it? And that's what we call merging surfaces. And we're going to do that with this command under surface called triangulation file utilities. Okay. So when we get this up, we need to first load in a tin file. That's our base 10. So I'm going to load the existing ground first. And you're going to see it show up here, and you can turn these on and off, and you can see that's, and I can even, spin it around just like in my surface viewer. Okay, so there it is. But you notice it does not have that building pad incorporated into it there. Okay, so I'm going to go now, after I've loaded that, I'm going to hit the next button at the bottom. And what I want to do, I'll go ahead and put this back like that so you can see what's happening. I now want to merge a tin file into this file. So when I choose that, I'm going to just take the defaults here and I'm going to say, take the second tin is inside the current tin's outside boundary with a transition. I can set the color of the triangles or not. And I'll just say, okay. I'm going to choose my pad and I'm going to add my pad into that surface. And so there's my pad shown as it would fit into that surface. That's all well and good. And now come down here to this bottom output, and I want to have all these checked on, and I'm going to say export, or actually not export, but save as. I don't need to export unless I'm changing formats. And so now I'm going to call this one my merged surface. Okay, it's now saved, it's done. I can do all kinds of things with that. I can use that as a new existing ground. Let's say I'm going to put a ditch down the middle of it, or I'm going to put a parking island and raise it up, and I can make that as a separate surface and then merge that one into this new merged surface. But just to show you what it looks like, let's go to view it. And there you can see how the contours would actually work if I turn those contours off, and then we can look at our triangle edges. You can see them the same way, or you can simply see the fact that, you know, one got put into the other, and it is now its own surface, as if we had built that and now called that our new existing ground. Okay. And that's the way we approach design, is that, let's say we are doing a parking lot that has, you know, some parking islands and stuff drawn into it here, and we know the parking lot's going to have a cross slope from up this corner down to that corner of a -3%, but we don't know where the elevations of those parking islands are going to go. So what you do is you build that surface, that pad, and then you set the slope across it as, you know, whatever your design constraints are, and then you build the parking islands as a separate little temporary surface, just like we did this pad. And then we merge the parking islands onto the parking lot. And then we can merge that resulting merged parking lot into our existing ground, and you now have everything all put together. Okay, so this particular one, in fact, you can do it as, well, let's just, you know, use that as a target. So if we have a, let's just do a real simple, I'm going to draw a rectangle just like this. And well, I've got, let me do that. I wanted to have a sloped surface on this. So if I'm going to erase those contours again by layer. If I have this one, and this is set at a constant elevation right now, it's the original drawing was 0. So let's say that's going to be my parking lot. And I would go back to my surface design pad template, and I would check on at this point to say use a slope pad design of a -3%. I've got over here, I'll just keep that. And keep everything else the same, except under pad, I'm going to call that one PKLOT, parking lot. I'll say, okay. It wants me to pick the polyline. There it is. Where's my target? That's the original existing ground. Let's stay with the 3-to-1 cut and fill slopes. And now it says my range, go from 1309 to 1319. So I'm going to go to probably somewhere around 13. Let's try 1304, the pad bottom elevation. So let's say that's going to be, say 1311.5. Maybe we have that from some other constraint. It wants us to pick the first point to define the slope direction. So I'm going to pick back in here. And I want to go down toward this corner at that -3%. Okay, so now I'm going to say, no, I don't need to adjust it. And if I look at that, or I'm going to isolate that and build the layer of that as my parking. So I'm going to triangulate and contour. I'm going to change the name of my file. I'm going to write the file. I'll select, I'll call it my PK lot. And I will use inclusions. I'm not going to contour it at this point. Just going to build the surface. So I'm going to pick, this is my inclusion, no exclusions, and select my data. There it is. I've now built that one called parking lot. Okay. And if I were to contour this parking lot, it would look like this if I displayed the contours. So you see the contours are now, you know, it starts high and it flows downhill to that lower area so that I know it's going to drain, right? I can even also tell that if I look at that elevation, I hover in that grip, I look down below in the status line, that's at 1311.90. I think I went the right direction. I may have gone backwards. And that's at 1321. Okay, so it drains the opposite direction. So it's actually, even though I'm in fill here, it drains 3% this way. Yeah, so I put my direction line in backwards. I should have gone in the other direction. So it's actually, even though this corner's in fill over the original ground, it still slopes down to this area here, which is into cut. So, you know, whatever that happens to be. Now I've got a sloped surface, but let's say I've got, now I want to draw some parking islands. I want to put them on there, but I have no idea what those elevations are going to be on that parking island. So I'm just going to draw a 2D polyline, say from here to here. I'm going to offset that, a standard offset of, let's just make it a 5-foot parking island from here to here. And I'm going to draw another 2D polyline. Let's go from, say, the midpoint of here. And now I've got that perpendicular, so I'm going to take that and just extend that along that line, say over to here. And I'll trim this. So I select my cutting edge, I trim, take that off. Now I'm going to offset this one 2.5 feet each direction. So I'm going to say 2.5. Go from here to here, here to here. I no longer do this. And I'm going to trim out that. So I'm going to select that, right click, trim that. So now I've got that. I want to put little rounded corners on the ends. So I'm going to put in I'm going to draw an arc, a PC, a radius, and a PT. So if I start here, and I know my diameter of that circle is going to be 5 feet, so my radius is going to be 2.5 feet. And I'm going to come up to here, and it asks me, is that direction correct? Yes or no? I'm going to say no. There it is. That's correct. I'll repeat that, or I don't even need to repeat it. I can simply copy it or even mirror it. So if I mirror that, starting of the mirror line, I'm going to say use the shift right click midpoint. If I can find my midpoint snap. So I would go from the middle point of that. And now I want it to be over there. So I need to go shift right click perpendicular to that line. Delete the original, no. And it mirrors it across the middle of this line along a line that is perpendicular to that line. So now there's that cut. I can do the same thing here. Because I know these are perpendicular, I will simply copy it from its center point. So I'm going to say right click, shift, hold the shift key and right click, center of that arc. And I want to put it at the point that's halfway between there. So I'm going to hold the shift key and right click and choose mid between 2 points. And I'll give it that endpoint and that endpoint. So now it's copied, but I need to rotate it. So I'm going to select it and come over to my modify and choose rotate. And I'm going to rotate it about the center of that arc. And I want to rotate it 90 degrees or minus 90 degrees, actually. Otherwise, it would be up inside. All right, so now I've got what looks like some parking islands in my design. They're all individual pieces of elements, but if I want those all to become one element, I'm going to go up to my, excuse me, my polyline toolbar, and I'm going to choose this join, or I'm going to go to edit and choose join nearest. And I'm going to say just directly connect the endpoints. I don't have any particular gaps up here for a separation. And I'm going to, oops, let me repeat that. Convert into polylines, join only identical elevations, which won't have any effect on us. I could say join only identical layers, but I don't want that because those are on 2 different layers. I'll say, okay, so now I'm going to pick these, and the last thing that I pick will be the layer that it inherits. So I'm going to grab all of those things. The last one I picked was the yellow. So now it's all there. It's all one unit. It's a closed polygon. All right. Now, remember, we built this parking lot surface, and it has a slope of 3% from this point down to this point up in here. We don't know the elevation of this island, but if it's going to be sitting on that surface, how do I put that on that surface? And you remember when we were drawing the break lines and we drew the 2D polylines and we said 2D to 3D, and we had the choice to go by screen entities, so it crossed the polylines and read the elevation. We have a similar tool that's going to allow us to take this 2D polyline and put it on, instead of screen entities, this time a surface. It's what we call draping onto a surface. And again, it's under civil. So under 3D data, that's 2D to 3D. And this time, instead of by screen entities, we're going to choose by surface model. So if we say that and choose our parking lot, it wants us to now select the polylines and lines to convert. There's the one. That's all I have. I hit enter. And if you add vertices at grade breaks, if this were a not uniform surface, you would want to pick up those. So it won't matter if you have them or not. You could keep the existing 2D. We'll not. We'll just go ahead and let it become a 3D. And you could then apply a vertical offset if you wanted to. We're not going to at this point yet. But again, if you were designing, say, a water line, you put the water line in here to here, draped it on the surface, and then drop it down minus 3 or 4 feet. And then we're going to set our layer name for the converted. I'm going to put it on 3D break lines and say, okay. And there it is now. It is 3D. And it has elevation. We did not put the breakpoints in because it's only the endpoints that hit that surface. The breakpoints would have been, you know, individual. Every time it crossed a triangle around there, it would drop a point. But it's all a nice linear, consistent surface, so it has the very same effect. So now, what do we have? We have, if I look at this in my 3D viewer, you can see that it has placed that right on that surface. Okay, that's what we were after, because we're going to use that to build these curbs and then merge it into that parking lot. So now, couple of things we can look at under the inquiry menu. For instance, if we turn the not layer inspector, drawing inspector on or off, and then we read the prompt and it says inspectors on, right click to activate the pop-up menu. I'm going to right click and I want to say, look at my polyline data, which will show me my slope. So that's checked. That's what I want. Polyline data. And now as I hover the mouse, you can see that on that particular segment of that 3D polyline, it has a slope of 2.16%. Let's also turn on the direction. All right, so from right to left, it has a 2.16% slope. This one should be negative 2.16%. It is. This one is going to be 2.09, and that'll be negative. So it's because it is lying on a sloped surface of itself. You know, the ground underneath it is sloping like this. So we've successfully put that where we want it. I'm going to right click now and turn off the drawing inspector. And now I'm going to build that into a curb structure. I'm going to have a I want to have a let's put a curb, actually a curb and gutter on this if we want. So I've got this line that I drew and I dropped it right on that overall total pavement. Well, that really is what I want to use as my gutter. So if I go, and because this is a 3D polyline, I have to use that command to offset a 3D polyline. So I'll come down to my edit, 3D polyline utilities, offset a 3D polyline. And I'm going to go to, I want to offset my gutter and target the surface. So it's going to basically be the same elevations as I bring that up. So I'm going to say, okay. Round exterior corners, yep. And oops. Let me escape that. I hit too many enters. Say, okay, around the corners, yep. Slope format, in this case, it won't matter. I'll just say percent. So I'm going to offset this polyline. I'm going to target my parking lot. And my fill is going to be at a 0% grade as well as my cut, because I'm keeping the same elevation. And I'm going to offset this side. Actually, I think, no, let me undo that. That was the wrong option to use. My apologies. Let's go back to my 3D offset. Let's just do it as an interval because I know that'll work. So my horizontal, let's say if I go with an 18-inch gutter pan, I'm going to say 1.5 feet, so 1.5 horizontally. My offset amount is going to be 0 vertically because it's going to be at that same elevation. So I select this and then I come to the outside edges. So now that should also be on the same, it should be on the surface of the parking lot. It's actually not, because this is the one that's on the surface. I went a distance out, and so now this distance out here should make a different elevation if it's on the surface. So what I would do in that scenario is re-drape this onto the surface just like I did this one. Okay, so that my edge of the asphalt is going to be out on the surface. In reality, we would probably have drawn the outside line first to have set that, but so let's do that. I'm going to go first to my edit menu and I'm going to change that 3D entity back to a 2D entity at an elevation of 0. And I'll pick that. It's now a 2D polyline, which I can tell because I see those little midpoint grips. I'm going to go back to my 3D data and say 2D to 3D by surface model, choose my parking lot, choose my edge of my gutter, and say, okay. All right, so now that's at the right elevation. And you can see it's going to be slightly higher. That's at 13, 18, 38. That's at 13. Well, not enough to see the difference. That's at 20. That's at 27. So there's a little bit of difference there. Okay. And so now now that I have that gutter line, this one was also done at the surface, but I want it to be a little bit lower than the actual gutter line. Let's just drop it, say, a tenth or maybe 0.15 feet vertically. And so again, on my 3D data, I can change the elevation of that line. Now, I could say absolute and it would set it to a constant, but I'm going to say differential. I'll say okay, and I want to go minus 0.1. Ignore zeros, it doesn't matter. I'm going to select this item. So it's now on the surface, but now dropped a tenth and a half. And just again, for some visual confirmation, I'll spin that thing up and take a look at it. And I see that indeed that outside gutter line drops down to there. Now I'm at a 3-time vertical exaggeration. So if I put that back to 1-to-1, you can barely see it, but it is there, slightly there. Okay. Now, we have all that we need to make this into a surface, which would just be the gutter pan, but I want to raise this up to my top of curb and then offset a back of curb. So we're going to go back to our edit, 3D polyline utilities, offset the 3D by interval. And again, we're going to do just a wee smidge. So 5/100ths, because I can't have a vertical face. And how much do I want to raise or lower that? I want to raise it up by 1/2 foot. I'm going to select this polyline and I'm going to go to the inside. So that does that little bit of lean back. And now I've got that one, which is, if I look at these two right in here, and if I hover in that grip, look at my status bar, I've got 13/18/23. This one is 13/18/73. So that's what I was after. Okay, so I now have the top of curb. Now to get the back of curb, I'm going to repeat that 3D offset by interval. My horizontal distance, since I went back 0.05, let's go back 0.45. So total would be 0.5 from the face to the back. And I want to make a 0 vertical difference. So I'll take this and go to this. And now, when I look at that structure in my 3D viewer, you're going to see everything we need to build that curb island. So it's going to drop down from the gutter line a little bit, come up 1/2 foot, and go back 1/2 foot. All right. And if you were to do that, what's the elevation going to be in here in the middle compared to the elevation along this line? It's going to be exactly the same, right? There's nothing in there that says make it different. So it's going to be a it will be flat. It won't be level. It will be this, it'll be a flat edge to edge across there. But what if you wanted a raised sort of dome shape island in here? And there's a way of doing that too, is that we're going to draw a we're just going to draw a 2D polyline again, and we'll draw from right here at this midpoint. Now these, I'm just going to click here and draw all the way across to here in the midpoint. And I'm going to do the same thing, repeating it. I'm going to start down here. Oops. I think, you know, it's halfway. And I'm going to come back here to say perpendicular to, so shift right click, perpendicular there. I'll now use this to trim this, and I've got a couple of things I need to do. I've got elevation along this. I don't have elevation along these. Okay, but I'm going to set the elevation of this based on where it starts here and where it ends over there. So I'm going to go to 3D data, 2D to 3D by screen entities. I'll select this thing to change. I'll use this as my matching source. And now when I look at this, I see hovering that grip, I've got an elevation of 1319 on that side, 81, 1317, 64 on that side. So now that's been elevated to that particular point. Actually, maybe a little better way of doing this. If I draw, let's draw a 3D polyline from the end of that, instead of trying to interpolate that circle, I'm just going to go from end to end. I'll do the same thing here and to end. Now it's reading the elevation, so I don't have to do the conversion at this point. And I'm going to do the same thing here now from this endpoint to this endpoint. So now I've got targets, and I'm going to draw another 3D polyline. I'm going to go from the midpoint, so shift right click midpoint, to shift right click midpoint over here. It's now been set and it goes to that midpoint. I can choose it again to go from the shift right click midpoint of this, and I'm going to go shift perpendicular to this, and 1818. Okay, so that now, and if I no longer need these, show you why in a second. So if I take a view of all of this information, I just want to make sure that everything is like I'm expecting. So I've drawn that purple line to lie right flat on that, what would be that surface if I were to build it. All right, but I want a little bit of a crown. I want to raise that up. So I'm going to raise both of these two purple lines with my 3D data, change elevations by differential, and I'm going to raise them up a positive 0.2, so 0.2 feet. I'm going to choose those two lines, and they're now raised up 0.2 of a foot. Higher than what they were before. And now, excuse me. Excuse me. So now I've got everything that I need. Do that again for confirmation. All along that. So my purple lines are all connected. I've basically created the ridge line. You see how it sits up in the air a little bit above that? So I've now created the ridge line to form that raised hump in my line. And when it gets out here to the end, it's going to jump down here. So it's going to round that down, and then it's going to round down to the sides of each one of these things. So basically what I've done is created a series of break lines that I'm going to use. But if I look at this and I see I've got a point out here and a point out here and no points in between. Same thing for this one. I don't have any points in between, but if I want that to be a little smoother, I need a little more points along there. I can densify that to where I can add points along the line, but I don't have to do it into the drawing. I can do that as part of my surface model. So let's go back to our surface menu and triangulate and contour. And this time where it says write the triangulation file, I'm going to say select, and I'm going to type the name island. There's my parking island. I'll say that. And I will tell it to use inclusions because I've got that outermost line. And I'm going to tell it to densify these break lines. And I'm going to go just every 5 feet should be sufficient. And I will make sure the contours are off. I'll say okay. Select entities, read the line above, the inclusion perimeter. There it is. No other inclusion. So I hit enter. And then the exclusion parameters, I don't have any. I hit enter. And now select the things that I want to triangulate. There they are. Surface is built. I look at that surface again for that confirmation. And there you can see how the gutter drops down. The curb steps up. It goes flat across the curb tops and climbs to that ridge in the middle. It's just 0.2 of a foot higher than the flat across. Okay, so now what do I do with that? I've got this surface. I now have this surface. So if I merge this into this, that's my finished parking lot. So I'm going to go to my surface menu and choose my triangulation file utilities. I'm going to load my parking lot. I'll go next, and I'm going to merge the island. So it would look like this now. You see how that comes right there, and it drops down into the gutter pan and climbs up into that raised dome, the crown. I'm happy with that. I'm going to say save as, and I'm going to call this parking lot dash FG for final parking lot. And if I repeat the commands now, let's just load, excuse me, the overall existing 10. We go next and we merge the parking lot FG, which includes the island. And then we save as a merged, let's just say PKLFT, merged parking lot. It's now saved. And so what do I have left? I've got my merged park, or not merged, yeah, merged parking lot. And that would be, if I were to draw the contours, they would look like that. And you can see how the curbs were then, designed independently, draped onto the parking surface, merged into the parking, and then the parking total merged into that existing grade. And that's your final design. You can now, draw, we can turn back on, let's get everything on, we freeze the brake lines. We might want to leave that one drawn here, but then this is on 3D brake line. Those you might, we would want to have those as 2D polylines somewhere else to be able to draw that as part of our site plan. So, and then you can contour that. So if we contour from a TIN file, we're going to use the parking lot future grade as the contours. And I'm going to say, yeah, just one pair. Inclusions, no exclusions. All right, so there it's labeled all of our contours and it's drawn something here, but you see this is a continuous contour that goes across here, hits that structure, goes up, comes back, goes across, comes back down, walks itself around, and then all the way back out to here and come around the edge. Now that to you should seem to be quite a bit simpler a process than trying to figure out what all of these stupid elevations are if you're trying to design it. Maybe all you've got are these corner point elevations, and you've got to create this kind of a surface or these kind of structures. So break it apart into little pieces, do them together, and then use that triangulation file utilities to do your merging. Okay. So now I know everybody's probably a little bit bushwhacked right now because there's a lot of stuff that came at you. So like my granddaddy used to say, drinking out of the fire hydrant. So you might get a drink, but it's going to come at you. So we're going to take a little bit of a break and then wrap things up with that last final little design that we're going to finish some of that similar type tools. We have one more set of tools to look at, and that's our profile design, then our road design, that sort of thing. So you can go ahead and save this if you want, or save as and give it a different name. One other thing I did want to show you before we leave this particular file. I'll show it to you here in a minute. If I trying to get rid of these. Oh, actually, I took that. Go back to the contour that. Contour from the tin file. And I'm going to contour that finished parking lot. And now the labels, I want to label the indexes only. There we go. Okay, there we go. So that goes from 20 down to 15. It drops there at that 3%, and it hits these contours, walk its way across it. And as you can see, in our 3D viewer, this is all of that line work and the points and things. Those existing points, they're down on that where that existing ground was, but this is the resulting line work from the drawing. And I can go to this far tab at the top right where it says model. I'm going to choose that first button on the left to add a surface. I'm going to add the overall total merged with parking lot as a surface that's going to go underneath it. And there you can see. And you can see up here where these points are sticking through, that's where the existing ground was actually above that resulting parking lot surface, whereas everywhere you don't see them down in here is where it was filled on top of it. Okay. So good confirmation on your design, good visual checks, everything works out. Looks pretty good. All right. Now, one other thing that you can do, and if you go back to your settings, Carlson menus, survey menu, because we had, remember in our settings, in our drawing setup, I'm going to go to settings, drawing setup. Down in here, we set our coordinate system. So make sure if yours is not set, make sure you check to use a grid system. And you're going to use state plane 83, set it to PA South, Pennsylvania South, and then just say okay. Because if that is defined, you're going to be able to do a couple things with this. If you look on the let me see. Actually, I need a different menu. I could place an image by a world file, but I don't have an image for that one as well. So do either of you either Amy or Joe and Robbie, do any of you have the GIS module?
Yep.
Okay. Amy, do you know if you have the GIS module?
Was that do you mean one of the things that we had to download?
No, no, no. When
Oh,
if you go to the settings menu and choose Carlson menus, if you go to GIS menu, does yours come up and say what mine showed right here? Or does it say not available?
not available. Sorry.
Okay, so all you have is civil. Sometimes when they buy civil, they buy it as a suite and they get survey, civil, hydrology, and GIS. So,
Okay.
but this same type of concept will apply if you have an image and you have world file definitions that tells it where in the world that image is from. Like you can get that, you can download those from POSDA and download the world files with them, and you can use that even without the GIS module, but I don't want to take the time to go drag all that around. So I'll just show you visually what would normally happen. So if I switch to the GIS menu and I go to images, I can now place a Google Earth image. Okay. And I'm just going to call this one site location. So it creates an image file. And it now says, how do I want to tell? I'm going to pick it from the screen or from the map. I'm going to pick it from the screen. And I'm just going to give it a box that I want to use to cover that. And it's going to go out into Google Earth and grab that image and bring it in and place it where it's going to go. I can change the resolution, different types. I can use an aerial map or a road map or a hybrid. Let's use a hybrid and say, okay. And it's going to calculate some things. And there now is your site. And I mean, you may know, being from southwestern Pennsylvania, that when you come off the turnpike, come down here, here's that big truck stop area, and there's that little, yes, this is well, actually, we didn't go out quite far enough. I think this is Gateway Plaza right back in here, and the truck stop area is over in here. And then this, or actually, we may not be, in fact, let me go a little further afield. I'm going to use Google Earth again. I'll call this one site location from the screen. And I'm going to go from here. Let's go like enough out. I hope I can get it off from there. Oops. It's a little too big. From here, I don't know how far it's going to go. It's going to give me their high resolution. So if I do that, when it brings this down, you may recognize it. I may be a little too far. Yeah. So Gateway Plaza is right here. Okay, that's where you can go in there to the restaurants and such. The truck stops back in here. There's that little road that connects. There goes to the ramp up to the turnpike when you're coming back on. This comes down in the ramp up to I-70 out toward Maryland and DC. So that's where that is. And you can see, you know, the aerial compilation pulled all that from the image. Now, one thing to note about that is when you use Google Earth as an image source, look at the corner of that parking lot right there and right there, and you see the purple lines. They don't exactly match up, and that's because the Google Earth image is not all that accurate, but it's at least within the ballpark. And there are other tools with other modules, like if I go to my CADNet, and I can go to raster and rubber sheet. And I can say go from this point on the image to this point on the ground right there, and maybe another couple of spots that, you know, I can fine tune. These parking lot corners are really the easiest to grab. Let's say go from here in the, here's my, there's another faucet where it is, say right here in the image to right here on the ground. I'll just do the 2 points, and you can see when it finishes, it's going to warp the image into fitting, you know, where I told it to go from here to there. And here you see how I tied it in, and it warps it together. So there's tools to do that, but even without all of those extra tools, you can go to POSDA and download that from a GIS source and get the actual ortho-rectified image and have it overlay right smack onto the right coordinates, as long as your settings and your drawing setup is pointing to a proper coordinate system. Usually it's going to be the local state plane. Okay. Now, with that being said, and I promise you your break, you're going to get one here. Let's go ahead and we'll come back right on the hour at 4 o'clock. And then we'll wrap some things up. We'll talk about this overall process, which we've just actually done through all of this, but we'll show you where it is in the training manual and how we can take it. You know, all of these things you've been doing as we've been going along. And then we can do that same type of thing where we model a, this is that putting it all together, we would model a stockpile, and it's how to build that surface. And then we model from inside of that another building pad, but this time instead of a parking lot of a building, we're going to use it as a borrow pit. So we drop it down to the inside instead of the outside. And then we merge that into the stockpile and come up with that. And then we put in a little alignment, and we get the existing ground profile under that alignment. And then we design a road profile through that. We generate that as a 3D line along this center line. We offset the edges left and right, drop them down at -2%, and then tie all that back into the existing ground, tie it into the surface. And then you're left with, you know, something that along these lines, you got this road that comes up, and it comes down and cuts through that little bank, and that's your haul road out of that borrow pit. Okay, so that's, we'll see how some of those things are done. But go ahead and take your break. We'll see you back here at 4 o'clock. I will pause our recording. Now, what we've done is a lot of what you're going to see in this final set of exercises. So we're not going to go through a lot of the detail in this, but I want you, when you get a chance to practice with the data, to go through this and read it a little bit better. So we're going to open up this file called example1.dwg. So, excuse me, I'm so sorry. I'll close that file off and save it. And I'm going to open this file called example1.
And this is the completed drawing, so you got something to compare it to. So example 1. And we bring this up when it comes up, and you're going to see a couple things. You're going to see what look like Carlson points, and they are. Okay. But so this is an existing drawing. It came from somewhere else, and there are points in it, but once it finishes loading here. Okay. So I see these points are in my drawing, but if I look up here at the top, I see my CRD file is set to none. So I don't have these points anywhere other than in this drawing. So I'm going to want to bring those points from this drawing into a coordinate file. So the first thing I'm going to do is go to my points menu. Well, first of all, I'm going to make sure I'm back in survey. And I'll go to points menu and excuse me, I'm going to set my coordinate file. And I'll just call this, we'll just keep it the same file name, example 1. And right now I was sitting on the existing tab, but I gave it a name that didn't exist. So it asked if I want to create it now. Yes, I do. There it is, and yet it's empty. So how do I get these points from the drawing into that coordinate file? So in case I lose them out of the drawing, I can recreate them. And that's, remember, our coordinate file utilities. We can update down here on the bottom 2 buttons. We're going to update the coordinate file from the drawing. And we'll make sure our wildcard description has asterisk, meaning take everything. And we'll say okay. And it says select the entity you want. We're going to take all and bring them in together. And now if I list my points and choose all, I see that I've got, starting with 2000, 2001, I've got all these distant descriptions of boundary toe or stockpile. It's B-toe and then B. It's 2 different descriptions. So that's what I needed. So I've got all of these B points and I've got all these B toe points. Well, the toe is my toe of slope. The ones without the word toe is not the bottom of the slope. So we've been talking about, you remember, we've been building those terrain models. So let's build this. Well, first of all, let's take a look at what we have. I'm going to look at my 3D drawing viewer, and I'm going to see that, in fact, what I have is just a series of points, not a whole lot of data. I have no break lines. And if I were to model this as a terrain model, I'm going to get triangles out in this area here too, because this point 2014 is going to be able to see this point 2010. So what do I need to do with this? Is put a boundary around it, right? What are some of the ways to do that? Well, we can shrink wrap. And if we draw our shrink wrap, it's going to look like that. And it looks like it modeled it pretty well, except for places like right in here. I went from all of these toe to toe to toe. Those are good. And it should have gone from toe to toe. This is actually a point right here that's in the interior. So I could come in here and remove that. That would fix that one. And I would look all the way around my site. And here's another one that should have gone like that. Okay. You could also, excuse me, have noticed the fact that the series of points in my list that start with 2000 and just 2001, 2, 3, 4, it goes all the way around to 2028. And those are all B toe points. So if I list my points, 2000 down to 2028 in order, those are all of my toe points along the outside edge. So I could simply draw a polyline that represents that, excuse me, represents that boundary edge by point number. I can do shrink wrap and fix those couple little places, or I can let it happen when I build the surface. So let's just draw a 3D polyline just so that we can get the elevations that we might want. So I'm going to use a 3D polyline. I'm going to turn off prompt for existing or prompt for elevation. So I'm going to have it read the points, and I'm going to put it on a layer called 3D break line, or let's actually call it PERIN, perimeter. Say okay, and I'm going to now use point numbers because I know that 2000 to 2028 goes around in order all the way around, and it ignores any of those interior points, but connects up all of the big toe points. And now I've got one, it's still asking for more points, so I'm going to type C to close. And so now I've got this nice figure that forms the, the bottom edge of that stockpile. Okay. I've got enough to build my stockpile, so let's do that. We're going to go to surface, triangulate and contour. I'm going to uncheck draw the contours for now. I'm going to triangulate. I'm going to write the triangulation file. I'm going to select, and I'm going to call that STK stockpile. Okay. I will use the inclusion exclusion areas because we just drew it. I can ignore any zero elevations. I'm going to densify if I need to. If I'm getting long lines, it'll draw some extra stuff in there. I'm not using contours, so I'm not minimizing flats. I'll say okay, follow my prompt, select entities, read the line above. There's the exclusion. There are no, the inclusion, there are no exclusions. And then I'm just going to grab the data. Surface is built. I'm going to view it, my 3D viewer real quick as my stockpile. And I see, in fact, there's what it looks like. And you see, it's got some problems like these long triangle edges, these ridges and stuff. And there's some refinement you can go through. And I'll leave that, to you as a separate exercise. But for what we have, that's as good as we got. That's as good as we know. There's my stockpile. So how do you tell how much material's in that stockpile? What would we do? We need to run a volume. But remember the one we did before where we did for the parking lot or the building pad, we started with an existing grade and we went to a final grade. We compared two surfaces, but I've only built one surface on this drawing, correct? So how do we do that? If we look at surface, we have volumes by triangulation. One of those options is a one triangulation surface volume. So I could take a peek at that, and this file that I want to use is my stockpile. And now it wants to know, well, what do you want to use as a reference? If I said elevation, I would have to know sort of the average elevation around this outside edge and use that. Or I'm going to use the 10 perimeter because imagine if all of this data was sitting on the existing, ground, and that existing ground was on the side of a slope, on the side of a fill slope. So that bottom of that stockpile is not going to be level. It's not going to be at a given elevation. It's going to be along the surface that boundary that we just created sits on. And so if we use that as a 10 perimeter, that's going to be as if we had built a surface and only used this boundary, did not use any of these interior points. So we only used that edge, and it went from the edge to straight across and made a flat floor to this as a surface. So we could have built that separately, done those as two volumes, two surface volumes, but we're using one surface and we're gonna allow it to use the 10 perimeter. And we'll say, okay. All right, so shrink and swell, again, if you have all of those different things you want to use, we don't have, we're gonna say, okay. And there's now our volume, so we see that we have a, we got a slight little, we got a cut volume of 1.5 cubic yards and a fill volume of 3287 cubic yards. And what this particular cut volume represents, see, really, we're not doing any cut. It's all material that sits on the ground. But there's a little corner up in here that sort of, tucks up above and it sort of folds the edge a little bit. So when it computes that volume, it picks up just a little bit of material in there that we can safely ignore. So we got about 3,200 yards of material in here, all right? Now, remember our goal is to design, and I'm going to let you go through all of those different nuances as it talks you through all of that. But our goal is going to be to design a borrow pit in this stockpile. So I want to draw my boundary of my borrow pit. And this time, instead of like the building pad in the parking lot, we went to the outside, we're going to go to the inside. Right. So, so we're going to draw their contours just so we can see them for reference sake. And I'm going to get rid of all these points. I don't really need them anymore. I've used them, all I need to do. So I'm going to go to points. And you can either freeze the point. Let me see what layer. First of all, they're on layer P&T. I can just freeze that layer. So if I freeze, sorry, if I freeze and I pick the point itself. Now all my points, they're still in my CRD file. They're actually still in this drawing file, but I've frozen them off, and this is just the outside boundary. Gives me a good visual reference. I have a surface, so let's go to the surface menu and let's contour from a tin file. And let's use that stockpile. And I believe reset a particular interval. I think 1 foot are fine. I can use this inclusion exclusion area if I want. I don't need to because the edge of the surface will define it anyway. We'll just leave it on. And let's go to the contour tab and draw the contours. And now we see these two layers, V, surf, cont, INT. That's the intermediates on V for survey, surf for surface, cont for contour, INT for intermediate. We check on to draw the index contours, do the same thing with that, except it says IDX and a 5 foot. Turn my smoothing off and my labels, I'm going to label the contours and I'm going to label the index contours only. So it's going to go on V surf cont IDX, same layer. And let's see, let me change my, that's fine, I leave my style to standard. And what do I want to do? I want to, let's make these a little bit smaller labels, so 0.06 tenths, so 6/100ths of an inch. I'm going to hide the drawing under the label in case I need to move them around. I'm just going to put one per contour. I'll say okay. I'll ignore all those and I'll draw these. And so now there's my labels. And I can go back to surface, contour the surface. I guess it's under contour utilities and survey. So I'm going to move the label on the contour. I'll pick that text and I'll bring it around here so it's not on like right on a bend point, just so it's out there where I need it to be. All right, so that's good. So I can see that that's 395, 96, 97, 98, 99, 400. So those are 1 foot intervals. You see the elevations accordingly. Now, we won't take the time, but this will step you through showing you how you're going to do things like when you finish this up, I'm going to change those layer definitions that you see right now are white and red. They're going to be gray and they're going to be, you know, dashed patterns and all of that. So to look more like existing contours. We'll leave that for a little more leisurely pace through the design. All right, so we've got this designed or contoured rather, and let's now go and design our borrow pit. And we're going to look for this elevation. That's going to be what we set it to when we draw this. Now we're going to just sort of find, you know, sort of where that happens to be, make sure we're within here. So I'm going to draw a 2D polyline and I'm going to put on a layer here now called borrow pit. Say okay. And I'm going to turn off my snapping and I'm just going to sort of eyeball, you know, something close to the edge, but I don't want to get too terribly close because I want to have, you know, some room for it to go off, you know, toward the edge if I need to. So now I'll come back up to, say, here and then C to close. So that's going to be the boundaries of my borrow pit that I'm going to design. Okay. I've just drawn a 2D polyline at 0 elevation and just sort of placed it where I want it to go. Remember, I've got like 3,000 yards of material in the stone pile. So maybe I need, you know, say 1,250 yards of material. That could be my target that I want to get out of this borrow pit. So if I go next to my surface menu and do a design pad template, I'm going to target my surface file that's up here at the top, but this time I'm going to go to the inside, not the outside. And I'm going to uncheck this slope pad design because it's just going to go down to a particular elevation. Right. And, oh, I'm sorry, this up here at the top. Yeah, no, that. Just for a minute. Yeah, we're going to target a little bit misleading there, but anyway, if I put that on that surface file and I'm going to let it run down to the inside. A particular elevation. I'm missing something here. Bear with me just a minute. Let's see. So that's now drawn as the bottom. Okay. So actually in the example, when you go through it, you're drawing the actual bottom of the borrow pit and you're going to do the pad design to the outside. So it goes up and intercepts the existing grade instead of what we're doing here as the outside edge going down to a particular
elevation. So either one of these would work. If I go to a particular elevation on the inside, and let's now say this is checked, this is checked, we've got a spacing, we've got a risk, we're going to go to our pad layer and call it just pit. I say, okay, pick the pad polyline. And as I say, pick the pad polyline, so we're using default of 0.5 since the storage setting is below the minimum for the pad cut grade. See what's escape that and time run this again. If I go to the elevation to the inside, minimum cut fill points. That should do. Now if I pick, oh, you know what? Sorry, we're trying to take that from 0. What we need to do with that first is to drape this. I'm going to come in here and say remove that for a touch just to get there. So if I drape this on the pad or on the stockpile itself, so it lies along the ground, along those edges, and then we're going to go down inside to a particular elevation. So that's sort of the backwards approach to what you see in the book. As you go through it, you're drawing the floor, and then you're still coming out as if it's a pad like we did before with the parking lot. So if I drape this line first, if I go back to my civil menu and choose 2D to 3D by surface model, there's my stockpile. There's my polyline. I will add vertices, add all the grade breaks, and I'm not going to set a different layer. I'm just going to let that convert where it is, say okay, and now this has been draped. You can see right onto that surface. You can see it there. It's now rides along the ground at that definition. And now, if we go to our surface menu, use design pad templates, go to the elevation on the inside. This should work now. We say, okay, we pick our pad polyline. And let's use 2:1 as our side slopes. And our target surface elevation, remember over here was this 394.5. So we're going to 394.5. And that's what it would look like here. Do I want to adjust any parameters and redesign the pad? I'll say no. From there, it's done. And now that's what it would look like if we cut it down to that elevation. Now, if that's even enough, let's see what our volume might be. And we can do that if we're in our civil menu and we're on that surface. And let's choose edit design pad template. We'll choose the outside edge of our pit here. We process it. Oh, let's see, it can't do that unless we use the surface, which we did not. Okay. All right. So let's do a little bit of a change of plan here. So I'm going to erase by layer. So edit, erase by layer. I'll clear if there's anything there. I'll select from the screen. I'm just going to pick one of those blue lines. And there now is this line. I'm going to turn that back to a 2D, edit 3D to 2D. And I'll set it at an elevation of 394.5. And there's the one I want to change. I can now also edit polyline utilities, I can reduce the polyline vertices, take my default, set that, and so now I should have just the corner points, that's fine. And I'm going to bring this into a little bit of a smaller area because I'm doing the bottom instead of the so that's going to represent the bottom of my pad, and I want to make sure I've got enough room to catch. I don't want to run off the surface. Let's get rid of that vertex. Okay. That should be the picture. So draw something like this, and we're going to use this as a pad for a different elevation. So I'm going to select that polyline, and I'm going to set its elevation to 394.5, or, and you can see 394.5 would be lower than 395, which is the low side here. So at 394.5, we're going to set that to be the bottom of our borrow pit, and we're going to flare it up into this surface as a target. So let's go back to the surface menu and design pad template. And this time we're going to target a surface file, and we're going to go to the outside. So we have a constant elevation across the bottom, and we're going to go out away from it until it hits this surface. Okay, so I'll say, okay. I'll pick my pad polyline. I'll pick my target surface. I'll use 2-to-1s. And it says, now do you want to adjust and redesign? I'm going to say no, everything fit within where I was looking for it to fit. That's all in good shape. I have everything in cut, which is what I want it to be. I can tell it by it's red. So I'll say no. And now I can go back to my surface, edit pad template, and to pick the polyline, I'm going to get the one along the bottom. There's that elevation. There's my side slopes. Let's see if I move the pad just a little bit off that back edge. Let's do it like that and reprocess. That gives me 1,600 yards of cut. But let's say if I need 2,500 yards out of that, well, that's going to go actually below the bottom of the stockpile anyway. So let's go to, let's say we're maybe 2,000. So if I balance this, I want to balance to where I have to carry away 2,000 yards of material. So that's my balance criteria, not 0, 0, which is balance cut and fill, but I want an actual balance of cut to be 2,000 yards. So I say, okay, and so it makes it a little deeper, and you can see it changed the elevation down a little bit, 393.71, and it set the amount of cut volume to 2,008.5 cubic yards, right? So that now would be what we're going to use as that borrow pit additional surface. See, we've just now got that done. If we go back to surface and edit the pad template again, just to, and the only reason I'm doing this is to be able to just write the 10. I don't want to have to go to the trouble to create that surface. I'll let this tool do it. So I'll just write the 10, and I'm going to call that one my hit. Okay, so now it's done that. I'll exit it. I will view. I'm going to show you another little trick on the viewer. If I load up my surface file viewer, the 3D on the view menu, 3D file viewer, surface file viewer, or choose it from the toolbar. And let's load the stockpile. All right, so now you can see it, but let's go to our model tab in the top right and choose this button to add a surface. So we're going to add another surface, this one called pit, and it's going to superimpose the two. It's now in there, and I can't see it because I'm all colored in solid there, but I've got it showing underneath here. If I go to my view control and uncheck that, I can see that I've got one at the top of the other. I've got the one underneath the other. I can make it solid again. I go back to my model tab, open up this list of surfaces that are in here, right click and choose surface properties. And I'm going to make it transparent, about halfway transparent here. Say okay. And now you can see I've got the one surface. It's still, but it's see-through a bit, so I can see where I'm going with that design. Okay. I say exit to that. So I've verified what I wanted to verify. I now know where I'm going. And now we're going to bring our haul road in to our area. So we're going to just simply go to our draw menu and draw a 2D polyline. And we'll change the color and we'll make this one say red. And we're going to put it on the layer called haul road. CL for haul road centerline. And we're just going to pick some points. So I'm going to pick, say, a point, I'm going to shift right click nearest. I'm going to start right here on my edge. And I'm going to come down to here and click a point. And I'm going to come across to here and pick a point. And then I'm going to turn and go sort of 90 degrees. So perpendicular snap into that green one. So there now, let me change this to, let's make it something instead of red. All right. So that's going to be the basis of my road design. However, I can't have these square edges. Remember, we did that center line yesterday. So let's turn that into a center line and make it a little smoother. So let's go to the center line menu and let's choose polyline to center line file. If I choose that command, it wants to know the file to create. And I'm going to just call that haul road, HAULRD. I'll pick that center line, take the defaults, and it's done. But if I look at it if I double click it and look at it in my editor, I don't have any curves in it. So I'm going to fit a curve between this one and the next tangent. So if I fit a curve of, let's say, 150, let's see what that looks like. So that puts this curve in here. It's nice and broad, maybe a little too big. Let's cut it down to, say, 100 feet. I want a little bit more left over at the end. There we go. So now I'm going to go to the line, the next line, and I'm going to fit a curve in there. And I need to make that one fairly tight. That'll probably be on the order of, let's use, say, 35 feet. Oops, it's too big. Can only use 27.65. So let's make it, say, 25 feet instead of 35 feet. So I didn't have much. And there's my curve until it comes down here as it ends on that last little piece of tangent. So I've got a big curve in here, short piece of tangent, and it goes around a 25-foot radius curve to get turned into my building pad. Or my borrow pit. I will save that. Exit is going to redraw, as you saw right there. Now, again, that's a 2D line. You see there the original outline and the center line is all 2D. You click back on this top to be back in plan view. And I need to make a profile along that line there. Okay. So to do that, let me go back to the survey tool set just so you can follow the same commands that are in the tutorial. So if I go to the profile, I need a couple of things. The civil tools in the profile have a lot more sophisticated design stuff and a lot more automation to it. But even if all you have is this, we can go to the surface, and there are profile tools down the bottom of this menu, whereas civil has its own set of profile menus. So I'm going to create a profile from surface entities or from a surface file. That's what I want to do, or from points along a center line. So I'm going to say from the grid or triangulation surface. And the surface I'm going to use is going to be my stockpile. And so I'll choose that as my surface, and I want a roadway type center line. And I'm going to give it no offsets for right now. That should be fine. I'll say okay. And it wants to know a name for that. So I'm going to call this Hall Road dash EXIST for existing. Well, let's see, let's spell it out. EXIST GRD. So that's the existing ground underneath that center line. And now prompts me to choose how I want to define that. So I have a centerline file. If I just type CL, that will bring up that file picker. There's my Hall Road. I'll say open, boom, it's done. Now I've got that profile. So if I go to my surface menu and I look at my profile editor, there's what it looks like. That's what the existing ground looks like along that proposed alignment. Well, that's not a very smooth thing to drive along, is it? So let's fix that. We're going to exit this now. We'll go back to that menu, surface, create profile from. We don't have anything that we've created it from, but we can do our profile editor, and we're going to choose new, and we're going to call this Hall Road proposed grade. All right. So now my editor is empty. So what am I going to add to it? I'm going to use down here below in the middle, this reference profile and reference centerline. And what that is if I set my reference profile to my existing ground, that gives me something to design against. And my reference center line is going to be my Hall Road center line, so it knows where to start and stop. Now, I need to put in a roadway set of curves to match this up. Okay, so I'm going to start out here on the edge. So I'm going to now start here at station 1, and I'm going to add a row, and I'm going to call this at station 0. So right here, what's the elevation? Well, I don't know without guessing, except I can come here where it says depth, and I can say 0 and 0 depth. So that's going to put it right on the ground. Okay. I'm going to come down here to my next one. I'm going to go all the way out to the end point. And that was station. If I look down here at my reference center line, it goes from 0 to 148.7692. So I'm going to say that's going to be 148.7692. And its depth is going to be also 0. I may have overshot a little bit. Let's take that to 690. What is it? Why is it not? Let's see. Let's set. Yeah, let's add this at 148. Oh, it's 7645. That was still too far. Let's look at the profile, reference profile. So let's just take that to 148.76. So 148.76. And we'll put that at a depth of 0. There we go. That's what I was looking for.
So we start and stop. So if we had no curves, you see right in here, I'd have a bit of, if I look up here, I'd have, it looks like 1.6 feet of cut. That's not too terribly bad. That would be sort of fine. But we're going to add in a curve. So I'm going to come down here. But I'm going to sit between these two. So I'm going to sit on this second one and I'm going to insert a row. I'm going to add a row. And I'm just going to sort of figure out where this middle point of this, maybe a little vertical, come in here, like, as I move the crosshairs, let's say I'm going to be at, say, station 40, and at elevation, say 396.5. So let's go to station 40 to 396.5. So that's put a PI in there. I'm going to do another one down here at the bottom. I'm going to be at, say, station 10 or 110, and I would be at 394.5. So I'm going to add a row at 110 at 394.5. Okay, so now I've put my vertical PIs in there. Let's turn those into vertical curves. Let me have one more out here in a minute. So if I come back to this particular PI, all I've done, I've got curves of 0 length. So I'm going to make that curve, say, 35 feet long. And that now gives me a nice rounded over curve. I'll come down to this one and let's make it, let's say 50 feet long. And then that gives me that last slope up into my building pad at 3.215%. Would be good. I could add another vertical curve to just flatten that out, but I think that 3%, that should be fine. All right, so let's save this and exit that editor. Now, nothing's happened out here in our drawing. Like in the civil tools, you would see all of this stuff get generated. But we've got a 2D line here as our center line, and we've designed a profile that follows those horizontal curves. So if I want to draw that 3D line into my drawing so I can offset some edges, we need to go to our surface menu, and we're going to choose the command profile to 3D polyline. So we'll choose that, and the layer name we're going to put it on is that same Hall Road center line, except we're going to change that from CL to 3D. So Hall Road 3D. We'll say okay. And now we're going to use the center line for the alignment. And the Hall Road proposed grade, which has our nice smooth vertical curves in there. And you can see that it is now drawn in there. If I look at that in my, let's look at it, say, straight on from, no, let's look at that in 3D viewer, easier. But there it is in plan view. If I scoot that all the way up and turn it around, look at it from the side and give it some vertical exaggeration, you can see those nice smooth vertical curves. There's nothing sharp about it. It flows right along the ground. Okay. So now remember, we've got a stockpile existing surface, we've got a pit surface, and we have a 3D line for our road here, but we haven't created a target for all of that stuff to go onto. So we would, in our documentation of the exercise, we're going to go to that surface menu, triangulation file utilities. We're going to load the stockpile surface.
we'll go next. We're going to merge the pit surface. So that's what all that's going to look like. We'll save as pit dash merge. That will be our new target for our road design. In fact, let's go back to that, and because I need to end on that instead of what I did before, which was just the existing grounds. I'm going to go back to that same scenario. I'm going to create a profile from a surface file using the merge, so I get the floor of the pit. I'm sorry, I left that part out. Roadway, no offsets. I'm going to use the haul road existing grade. It will be replaced. And my centerline file is now the haul road. I'll go to my editor, and I want to edit I want to make a new file out of haul road proposed. And I'm going to use for my reference centerline is haul road, and my reference profile the haul road existing ground. So now you see this almost vertical drop off that is coming down this cut bank into the pad. If I change my exaggeration to a one-time exaggeration, you see it's not really that steep. So let's maybe just leave it like, say, a two-time vertical exaggeration, but that gives me something to design against. So now I'm going to start here at my first station of 0, a depth of 0. I'm going to go to my last station, which is, if I use this one up here, 148.76. Make sure I'm underneath that 7645, because it doesn't have any more vertical information than that. So if I use that 148 point, oops, I'm sorry, the wrong box, 148.76, and it also has a depth of 0. All right, so now I'm going to add in a crest point here of at station, say 38, maybe, yeah, 30 or 40, and an elevation of, let me give that a little more exaggeration. So right in there, so station 40, and I want that elevation to be, what that's going to be like 396. So we're going to sit here and add 40 and say 396. Let's make it higher than that. 398. Put it too high. There you go. So it'll go right on the ground. And then I'm going to come down here and let's go to 130. So I'm going to add at 130. And I want to target that same elevation where it hits the ground at 393.7. So 393 point, let's call it 75, a little bit higher. It's almost dead flat as it comes into there. And now we need to come into that with a curve. So that should probably be sufficient. So this curve distance here will be 50 feet. And this curve at here, let's just make it a little bit of a vertical curve, say, wrong field, 35. All right, so 25, and then it finishes on that last tangent of an almost flat. It's a 0.2% flatten out grade. So we'll save that and exit that. Let's draw that one. Our profile to 3D profile. Say okay. Centerline file is Hall Road. Our Hall Road proposed grade. There now is our 3D element. And you can see that it is in fact drawn there up in 3D. So let's offset the edges. So that's going to be that 3D polyline offset by interval. Say, okay, I want to go horizontal amount. Let's just make two little 10-foot lanes. Let's go 10 feet. And we're going to go down. So we're going to use a percent. And the percent slope is going to be -2%. So I'm going to select that 3D polyline and I'm going to go to this side. There's now 10 feet that side. And I'll select the center line of the road again and go 10 feet that side. Okay. So there now is the edges of the road. Well, how do I tie that road in to actually, you know what? I'm going to run out of surface right in here. If I, let's erase those two lines for a minute and shorten up that distance. If I go back to 3D offset by interval, and this time instead of 10, let's just make a single 10-foot wide lane. And then percent of -2%. Go from here to here, and then from here to here. All right, that'll give us some room to catch. Now, we've got our center line, we've got the edges, but now how do we figure out the cut and fill banks on the edges of our road? Well, remember like we did our pad up here for our pit and our building pad, we're going to use that same command called surface design pad template, but it's not a pad, you say. Well, that's because this command can offset anything to that particular edge. And it doesn't have to be a closed pad, doesn't have to be a closed figure. If it's just a single edge, it's going to take that edge and target that figure, to target the surface. So I'll target the surface. And the pad layer now is going to be called Hall Road as my layer. And if I pick this pad and I want to go toward, I want to tie this into my pit merged. And let's go with, I'll just say 2-to-1 side slopes again. And we'll go to this side. So now that's what it needs to do to get that side in. I'll say no for that. I'm going to redesign or reissue the command and do the same thing for the other side. I'll pick this as my polyline. I'll pick my bit merge as my surface. I'll again say 2-to-1. And I'll pick this side. And there's what it would be on that side. No redesigns. Everything's good to go. I'll now isolate the Hall Road information. I'll verify it all in my 3D viewer, make sure I don't have any major gotchas. And I see, yep, there again, it's going to be, you know, cuts on those banks. And again, let's turn this back down to 1. So a little bit of cut on the uphill side, a little bit of fill on the downhill side. That should be sufficient. Now I need a perimeter. I've got this perimeter. I've got this perimeter, but they're for two different things. So I need a third perimeter that connects across those particular things. So if I do a shrink wrap boundary, And let's put this on a BDI called Dash Hall Road, or BDY Dash Hall Road. We draw and shrink wrap across everything here, and it now looks good, and it even goes up and includes the ends of that point there as well. So now I've got my boundary. I'm going to create that as a surface. So I'm going to triangulate and contour, change the name. I'm going to unlabel it, or uncontour it rather, not draw the contours. I'm going to write the file, choose, select, and I'm going to call this one just Hall Road. That's my surface file. I will use inclusion, exclusions. I will densify. I can ignore zeros. Nothing else I need to do. Say okay. I'll choose my inclusions, no exclusions. Grab my data. Off it goes. I'll verify it with a view on my 3D viewer. And indeed, that's what that would look like as a surface file itself. Give me more light on the picture here. You can see it. Oh, let's go back to this. Sorry, let's go back to this and turn the transparency back up so you can see a little more solid. There we go. So you can see it has a crown. It has it's got the cut slope and the fill slope in the places where it needs them. And it ties into, if I add that surface, which was the pit merged. You see there it is, and the road's going to come in here, and where you see it overlapping, it's going to cut down into it to build the road. So how do I do that? How do I add that back to it? I'm going to thaw everything here. Freeze some of these things out of the way. I've got contours, I've got edges. Got my existing contours, I've got these particular edges. And now to bring the road into that surface, I go to my surface menu, triangulation file utilities. I load up my pit merged. That was my previous target. I go next. And I now merge my road, my Hall Road. And voila, there you can see we've got a nice little road. It comes up our stockpile that goes into that volume of that borrow pit. We'll now save it, and we just call it pit merged dash final. We'll exit that. We'll view that in the full viewer, pit merged final. And then that's what it would look like as a grading design. You can then go to this model tab and you can change, give it different surface treatments like, grass cover, stone, any kind of things that you want there. Okay. See, all the contours could be drawn like that. And I'm going to leave that to you because you're now a half hour over. In fact, you all will get an extra half hour of PDH credit. But when you go through that, you're going to see in here, it's going to step you through some of the things that you can do to make this look more like, things like this, where you've got your contours, some shown as existing. So we're not going to take the time right now to
try to do that. You can see here, we've cut out the existing contours as it goes through the borrow pit, but we still show them as a different style. So all of those different things you can do, and you can do that because of the fact that you have those different surfaces created in our work. We've got, the Hall Road, we've got the pit, we've got the pit merged, and then we've got the pit merged final, which includes all of that stuff put together. Okay. So that's the essence of that last little exercise. Understand a couple of things. One, particularly for road design, a lot of that stuff, there's a lot more sophisticated tools available in the civil module. But this is one way you can do it, even if you don't have those tools, and all you're doing is really creating a little access road. You want to get that center line in there, you want to get it smooth, and you want to make sure it's drivable. And then just create it as a 3D line, offset the edges, tie those into the target surface that you're cut and fill slope, and then merge those surfaces together. That's the very essence of doing your terrain modeling, doing your surface modeling. When you're building stuff based on a set of drawings and somebody tells you, hey, this needs to be this elevation and that elevation and this elevation, you just create those. You draw the edges or you assign the vertex elevations and the properties. Like you can do, if it is a 3D line, you see here, I've got these individual vertex locations, and each one of those I could just simply come down here and give it an elevation. Or, and what I would do having civil is I would go to my polyline elevation editor, and I would take a look at that and see there. Now you see how that, and it's exaggerated vertically, but I could, turn on and off these different control points and let the slope change differently as I might need to. Or I would even go into my roadway editor and get all of those additional design tools. But that's for, it's a little bit beyond the scope of this class. And you can see, you can create the contours from the surface menu, contour from, and then you could have it add in the merged, or you could say just do the Hall Road. I find the Hall Road, there it is. And let's just draw them that we want labeled in there. Yeah. No inclusion, no exclusion. So there's now my Hall Road contours. They have to be the same layers as these existing grades. But you can see, based on if you go through these steps in the design here, all you do is when you run the contour from, you just give it different layer names to put those designs on, to put those contours on, depending on which surface you are running the contour. Okay. So that being the whirlwind tour, I will open things up now to let's see here, turn this back on. So I'll open this up to any kind of questions that you might have that you might still be looking for, or that you didn't get answered, and I realize you probably got 1,000 questions, but you should have a roadmap now to be able to go through the book again at a little more leisurely pace and understand where some of these tools are going to be located, come from. So anybody have any kind of burning issues that did not get answered?
Not necessarily any burning issues, more of like just what you said, kind of going through stuff again, familiarizing ourselves with it a little bit more. Just a very hands-on learner, and I feel like that's just all I need to do. We get like these recordings, right?
Oh,
Sent to
yes.
us?
Yeah, good recording from yesterday and today. I'll send those out along with your certificates. And it takes a bit of time for all of that stuff to process.
Right.
I get it up on YouTube, but within a day or two, you'll get them back. Maybe the first part.
Yeah, no, just
Okay.
me and Robbie been talking here about like, especially like for what we do, there's a lot of like tools we used that we'll be applying to the stuff we use. So we'll be going through rewatching a lot of that.
Yeah, absolutely. Yeah. So it doesn't, it doesn't always fall from just designing roads and parking lots and stuff. It's just a matter of, design pad template. That's a huge one when you do your grading design.
Yeah.
And the process there is you want to design, you want to get the 3D line work created and then add those into a surface. So you can either build it as a little mini surface that you're going to merge into another target surface later, or you can gather all that stuff up together and do it all at one spot. But you want to create the 3D lines. And the other thing to also remember in that whole concept is, these are all 3D, the things that I've turned the points back off. And let's even turn off the contours. Okay, so this is what we use to build those individual surfaces with. And so let's say we do that, and then we say, well, I want to come in here and I want to, I need to put a little cross ditch from the bottom of this over to my road. Well, you can do things like this. I can draw a 3D polyline, and I'm going to say, let's go from this point to this point. And then let's go from, say, this point over here to this point. And you see I've snapped into that. I've got the bottom of that, and then I can use that to target upward. Let's say that's going to be a little flat bottom ditch. So how do I get the resulting target? Well, that's again a design pad. If I go to a file, and we'll call this one ditch. I'm going to go from here. We're going to target the final, what we call it, the haul road final, bit merge final rather. And let's go just 2 to 1 sides, or let's go 1 to 1. And there's going to be a ditch, and we'll go. Let's see. There we go now. So we're going to go from here to pit merged final. 1 to 1. And we'll do the same thing, say no to adjust. We just repeat the command, and we go from here, same target, pit merged final. And same size, we'll go to that side now. All right, so once you've done that now, you can then take that same concept, and you've got this little pit, or this little cross ditch that connects the road into the borrow pit. And so how would you do that? Well, you might, isolate, you're going to isolate that particular layer. We're going to shrink wrap that so that it cuts across the ends. Let's see, what did I just do? Shrink wrap. Clear on ditch. Oh, I know. I've got a. Let's see, I guess I have to be in time. Yeah, there it is. All right, so I'll get rid of one of those. All right, so now that, even though it's a 2D, that it's still going to be a boundary, and I could make a little surface out of that called a ditch. If I step and say, come to each of the moment, triangulate, write the file, select it, we'll call it ditch. Save and
Say, okay, say, take that as an inclusion, no exclusion. Grab this, it builds it, I view it just for yucks to make sure. And it's gonna look like that. So it should, when I go through my compilation, I'm going to load that previous one, which was the merged, pit merged final. I'm going to go next and merge my ditch. Ditch. And you can see it down there. And it's actually going to look like that. It's got that little bit of a hillock, but it's got this little ditch across it. Now, you could fine tune that in there if you wanted. And obviously, when you're building that, you wouldn't do that. You would just knock this little hilltop off, right? It's just stuff you do. And then you would do a save as and give it a final name for that total, total compilation. I'm not to say that. But the point is, when you do all of those things, when you approach this in a piecemeal fashion, when you're designing, if you get into the design of things by thinking about edges and its contours. So your job as a designer, as a modeler, is going to be to create the geometry that controls this. And so even though I did that merge, I could also even do something like this line and this line. Really, and that's going to be, say this line and this line. And if I use that to trim with, I can cut out, these pieces. Let's see, let's take that out. And then just simply get rid of these pieces here. And so now when I look at that in 3D, see, I've actually made the edits with a couple of little extra things left over. Let me clean this out. So I've made some, just 3D geometry work. I can build walls, I can build these little things and put those in there. It doesn't all have to be done with those particular tools, but those tools can help the process. And then you would do the same thing, say for something back here. Click and trim, and we would want to get rid of, say, those edges, we get rid of, these things here that might be in the way. And so now you see, oh, there's one. See, and just use that 3D view stuff to be able to verify what you're doing, making sure that it's all going to make sense. And if you need to add more to it, or if you need to repair something, like right in there, I thought, no, it looks like it's okay. I thought I was missing that corner. So right there, that's a real quick and dirty way of, creating that little cross channel. And I've done it just by drawing 3D lines. I can draw a line across and drape it on the ground and then build a wall from it. If I put a 3D polyline, I'm not going to prompt for slope, but I will use the surface model. So, okay, I'm going to use the pit merged final. Pick a point. What's this? I'll do plan B. Use a surface model. Put modes final. So I'm going to put the, you see the little elevation marker up here in this little tracker. So if I pick a point here, I'll accept that elevation. Let's see. So and just you know, put a point along the ground here, and it's now draped onto the ground. I can even 2D to 3D by surface model. Put merge final. Take this. Use these. And now add vertices at grade breaks. Say okay, and that now has all of those things that go up and down to follow the ground. So now to create that as a file, what do we got here? I've got an elevation of 398. I've got 398. So let's say if that were a wall at an elevation of 410 feet at the top. Well, I might offset this one with my 3D offset command. To a constant elevation, a horizontal offset amount. Let's just go back 1/10 of a foot, and the elevation that I want to target might say be 410. I'll select this guy, even though it varies, and I'm going to go lay it back across the top right there. I'm going to now offset the wall. We'll make it a 2-foot wide wall. So we'll go horizontal at 2 feet, offset of 0. We'll take this and go to here. And now, how do I know where that ties into the ground? Well, I would do another type of offset of, let's just go that same little distance that we did for there. We're going to do another 3D offset. We'll target the surface. And we're going to go to a, we're going to take this and we're going to go at a, say, a 45 degree click to 8. So the surface I'm going to target now is going to be that pad pit merge final. And I'm going to go down at a 45 degree. Slope. And if I draw these, oops. Surface, but can't use. I'm going to grab this, use that, go up to the top, use, go across to the top, use, go down to the ground, use, and without going through too much additional stuff, let's take a peek at what we created. So now, I've got, you can see here where I've managed to build this little buttress wall. I put this line on the ground. I went up and then I laid it at a constant elevation, set it across the top at a constant width, and then I targeted back down to the ground at a 45 degree slope. And so, and maybe I don't even, maybe I don't use these, and I'm going up and going from the ground up to the top, across to the top, and then I'm going to use a fill operation back here to target this line as the back of my, the top of that wall. And so, all kinds of ways to go through the process and think yourself into 3-dimensional space
make sure you know that, you can move this stuff around and you can draw things by snapping to those coordinates and giving, let the elevations read and, create things. That it's going to be using. And then you do the same thing on this other side. Okay, or maybe it goes out and there's a foundation footer for it, and you draw that kind of slope in there, and you just generate all this stuff. And once you have that generated, just leave that in there and select it when you are building these triangulating contour. You're just making a surface, and it's going to include all of this stuff that you design and create. And it can be done as simple as drawing 3D things or design pad template to make enclosed pads, or design pad templates to take edges and target individual surfaces, or offset your 3D polylines like we did on the parking island in the parking lot example. Break it on the surface, and then we start manipulating all of those different things that change the elevation. But also remember, when you're doing this stuff, when you're working along and you are doing your work, if you stay in plan view, it's awfully difficult to try to get a sense of what's going on with that. So even if you don't, spin this up and start working in, now I'm holding the shift key and I'm pressing the wheel on the mouse and I'm pushing up and down and I'm keeping it all held together until I like it where it sits. But even if you don't do that and work directly in it, you can at least, as you're doing your work, select this stuff and verify it with the 3D viewer that Carlson supplies. And you know how to manipulate those views in there to see it. So let's say I like that, we verified what I wanted, but I wanted to work at it, spun up in this direction. Well, one of my tools on my settings tab is to come down here and say, save the CAD view. So if I click that, now it says that, now watch what happens when I exit. Well, there I am in that same view orientation. Okay. So all of those are some of those tools. And again, at this point, because it's all new to everybody, it's going to just take some getting used to. Now keep in mind, I've got about 40 years worth of experience on this stuff. Not trying to brag, you can tell by the gray in my beard and the peach color in my top of my head, meaning my lack of hair. It's not necessarily a badge of honor that I am implying there. It's just the fact that I've had time to learn those techniques. And I want you to start thinking along those ways. When you're trying to build this stuff and model this stuff, it's all about edges. That's all it is edges and points. If you have an isolated point, it all ties together. You know how to create your break lines. Now, if it's something that is an edge in your intent, your design edge, or if it is an edge that's actually out there on the ground when you are trying to model existing ground, just make it an edge in the data. Draw the 3D polyline if you have to, or if it's already drawn but it doesn't have elevations on it, use that tool under the 3D data menu in Civil to elevate those 2D elements into 3D elements based on them intersecting other three-dimensional elements. Okay? Fair enough? Okay, you guys have actually earned a full extra hour, not just a half hour. So thanks for sticking with
Yeah, we appreciate it.
Yeah, and like I said, any question you guys have, from what we're talking about here, you got my email, you got my phone number, all that in the emails that I've sent you. So get in touch if you have a question about something, and we'll step you through it, okay, or point you in the right direction on how to learn stuff. Okay.
Awesome.
All right, folks. Anything on your end, Amy? Anything you need to have cleared up at all?
Nope, I'm pretty much in the same boat. I just need to
Okay.
take some time to just try to use the software.
Need some time. That's true enough. By the way, you are an EIT now?
Yes.
or FE, whatever they call it these days. Does that carry with it a yearly requirement for continuing education like it does if you're a PE?
No, I don't believe so. I think only after you test for the PE.
Yeah, that's what I want. So, well, anyway, you'll all earn these credits for your continuing education. And if nothing else, it gives you that credit that you can keep any kind of a certification. But the real benefit I would like to think of is the fact that you can hopefully gain some knowledge and how to manipulate some of this stuff around. Okay?
Thank you.
You bet.
you.
You guys have a great weekend. Go home, have a nice cold drink, and don't worry about this. Don't break your brain till next week. Sit down and crack it open and start at it a little more slowly and see if you can seep in. All right?
All right.
Thank you.
Thanks very much.
All right, folks. You guys all take care.
Thank you.